So I have just one word for you, or maybe it's 2 words, I don't know, doesn't matter. Anyway, that word is microservices. Well, hello, wherever you are, whenever you are. Where am I? Melbourne, Australia, as usual. And when is it? It's August 2021. Now I hope wherever I find you, and whenever I find you, that I find you happy, safe and well. So yes, this is the big one. This is microservices. This is the course that I have been wanting to make for such a long time. And now it's finally here, free on YouTube. It was a lot of hard work, it was a lot of fun, but I'm glad it's done. Now, you will see from the timestamp that it's a long video, so I wouldn't expect anybody to go through it in one sitting. So with that being said, I have put the time codes in the description below. So that means you can jump to the sections that you want to go straight to, or you can come back and pick up where you left off. That being said, I do suggest you go through it start to finish for the best experience. Now, I have tried to put in the right balance of content for an introduction to microservices, but if you do have any feedback on how I can improve, please put that in the description section below. I always love getting your feedback. One last thing, just a big thank you. Thank you for joining me here on YouTube. And if you do like the video, please think about giving it a like. That just helps me out. And if you've not done so already, maybe think about subscribing. Ding the little bell, and that way you'll get notified when I make new content. And finally, to my Patreon supporters who go that little bit extra and support me on Patreon, thank you so much to you. I cannot tell you how much I really do appreciate it. And as usual, as a way of thank you, your names are coming up at the end of the video. That's enough for me. We have got plenty to get through, so I don't think we should delay any further. And I think we get started. All right, so yes, welcome to this step-by-step course on .NET microservices, and we will also be using Kubernetes, RabbitMQ, and gRPC. So up front, I just want to, this isn't the course outline, we go through that in a second, but what I want to be very upfront about is just the approach we take in this course and the type of approach I've taken, which may or may not suit some people. So I want to be very clear about that up front before you invest too much time going forward. So this course will focus on the technical aspects of building .NET microservices, which shouldn't be too much of a surprise. So hopefully that's why most people are here. We'll cover the theory as we go, but I wanted it to be as practical and as technical as possible. And so we do theory, but I didn't want to do so much theory up front that it becomes maybe a bit tedious. So we cover it as we go, but there is a bit of a theory block up front as well. Take a pragmatic, balanced approach, but always try to follow best practices. But again, you do have to balance that. When you are developing in the real world, it's not a highly theoretical place, and you sometimes have to make tough decisions, pragmatic decisions on how best to go forward. So again, I've taken that approach in this course as well. It's fully step-by-step. So the code is available on GitHub, but I don't point you to a repository and just tell you to download code and point at it as part of the video. We actually go through every single bit of code step by step, line by line, and that goes for doing Kubernetes stuff as well. So that might not suit some people. I'm just calling it out, but that's the way I've approached it here. It is fully step by step, and that's why it's pretty long. Already covered this, be as practical, as interesting as possible, but also acknowledge that microservices are hard and they don't solve every problem in the world. So we do have to go into the course acknowledging that that is the case, and I certainly try and acknowledge that. Some things this course doesn't do, so I don't focus on things like domain-driven design, bounded context, a lot more of the kind of highly theoretical stuff about how you would design your business-focused microservices. I don't really focus on that. We touch on it slightly, and I make the point about, services should be bounded, for sure, but I don't go into lots and lots of slideware or theory about that. We don't build out too much redundant business logic in our example. Our example is incredibly simple. Well, it appears incredibly simple. There are only 2 services, and you might think that's not enough to learn anything. Believe me, it is more than enough to learn the basics and the introduction introduction material to microservices, more than enough. And I felt if I introduced more services and tried to build out something like an e-com app, it would detract focus on really what I was wanting to try and get across. So we don't focus on, redundant business logic about building carts and, category pages and all that kind of stuff. Don't demonize the monolith or bandwagon jump. There are reasons and scenarios when you would definitely use a monolith and reasons where you would definitely not use microservices, which is probably the same thing. And I call that out and I give some examples of why we do that. So what I'm saying here, what I'm not trying to say here is that microservices don't cure everything. They're not the best approach in all circumstances, definitely not. And we don't cover everything. There is a balance to be struck, of course. You're never going to cover everything, and I certainly haven't covered everything here, but what I do feel I've done is given enough material that's going to give you a really good introductory foundation to building microservices with .NET technologies and all the associated stuff around that. I feel this course is going to give you that really good introduction foundation that you'll need to move forward. Okay, let's go through the course overview. So just FYI, there are 9 sections, 9 parts to the course, so we're just going to go through those now. So the first part is our introduction and theory, so we go through course overview, which we're doing now. Some prerequisites, which aren't mandatory, but kind of nice to have. The ingredients and the tooling that you'll need if you want to follow along. We then move on to some theory, so what are microservices, why you would choose to use them. We look at monoliths and why you would and would not use them as well. We then look at our services that we're going to build out. We do an overview of our solution architecture, and then we look at our service architecture, so how we're actually going to build our services out. We then start the practical build, and the rest of the course is fully practical from this point on, so it's all coding, config. So we start the platform service, which is our first service. So a bit of an overview of what it is. We scaffold it out, build out the data layer, and then we work on our controllers and actions. Part 3, we look at Docker and Kubernetes, so a review of Docker. We containerize our platform service, so we build it as an image and push it up to Docker Hub. We then go into Kubernetes, what it is, why you would use it. We look at the architectural overview of our application in Kubernetes, so that's the Kubernetes architecture section, and then we deploy our platform service into our Kubernetes cluster. And then finally in that section we set up some external networking so we can actually use our platform service inside of Kubernetes. Part 4, we start with our commands service, but really this section is focused on synchronous messaging actually. So we scaffold up our command service to start with, we set up a controller and action, and then we look at messaging, synchronous and asynchronous messaging. And as part of the synchronous messaging, we set up HTTP communications between both our services, our platforms and command services. So as part of that, we add a HTTP client to our platforms service. We obviously have to deploy our command service into Kubernetes. We do some internal networking, and we also stand up an API gateway. So it's a really big section where we cover an awful lot of material. Part 5, we move on to SQL Server. Every service has its own database, so this is the SQL Server for our platform service. As part of setting up SQL Server, we talk about something called persistent volume claims. We look at Kubernetes secrets. We deploy SQL Server to Kubernetes, obviously, and we revisit our platform service. And just a quick call out, if some of this stuff you don't know what it is, that's fine, we cover it all in the course. So if you don't know what a persistent volume claim is, do not worry about that, we obviously cover it in the course. Part 6, we revisit our command service and we talk about multi-resource REST-based APIs. So we review all our endpoints for our command service, we build out our data layer, and then we finish off our controllers and actions. That looks like a short section, but it's actually quite a long section. Part 7, we then look at our message bus, which is RabbitMQ in this case. So we do a review of our solution architecture. We give an overview of what RabbitMQ is. We deploy RabbitMQ to Kubernetes and we test it. Part 8, we then start to really build out our asynchronous messaging using RabbitMQ. So that involves adding a message bus publisher to our platform service. We look at event processing, and then we add an event listener to the commands service. And then to round out the course, we look at gRPC, so an overview of what gRPC is, why you would use it, all that kind of stuff. We'll do some final networking configuration inside Kubernetes. We'll then add a gRPC server to our platform service, we create a proto file or a protobuf file, and then we add gRPC client to the commands service. And to round it off, we deploy all that and we test it all end to end. All right, so let's move on to the course prerequisites. Now again, these are just suggestions. We do everything, as it says, they are fully step-by-step, but some of the stuff is quite complex. And if you've not touched it ever before, you might find some of the concepts a little bit heavy going. So I do have courses for all this stuff pretty much on the channel. So if you're a bit rusty, maybe you want to brush up on the following. So experience with building .NET Core REST APIs. So I have a full course on my channel that covers that in detail. Although we do it again here step by step as well, but I do spend more time on bits and pieces in that video. Understanding of Docker and associated concepts. Again, if you've never touched Docker before and you don't even know what it is, we do cover it here, but again, doing a more detailed course might help you out. Dependency injection in C# would be useful. Again, we do cover it here, but some of my other courses go into it in a lot more detail, the more sort of basic theoretical concepts. And if you've used async and await before in the C# language, that would definitely be useful. But again, that's probably not super critical. So all of this stuff would be useful. We do cover it all step by step. But again, if you've not ever built an API before using .NET, C#, you might find some of the stuff a bit challenging. All right. So these are the ingredients that you're going to need if you want to follow along practically, which I think most of you probably will want to do. So I'm using VS Code text editor. You can use Visual Studio if you want, but again, I'm deciding to use VS Code. I just find it lighter and more adaptable than Visual Studio, but you can use Visual Studio if you want. .NET 5 is sort of mandatory. There's some concepts in here. If you decide to use an earlier version of the framework, you may run into some little niggly problems, so I highly recommend you run with .NET 5. You'll need Docker Desktop running Kubernetes, again, which is free. An account on Docker Hub, again, which is free. So when we push images up to Docker Hub, you obviously need to have an account to do that. And you'll need either Insomnia or Postman, which are basically API test clients, which we will be using throughout the course to test our services. And in this video, I'm running everything on my local hardware. I did have a decision to make on whether to go with this approach, running everything locally, or whether to go with a cloud provider like Google Cloud or Azure. I decided that this course would be using just your local machine, so you don't have to sign up for cloud services, which I know doesn't suit everybody. But the downside of that is, yes, we will be running up quite a number of services, so you do need a decent level of local hardware. So I'll just show you my PC spec, just out of interest. Now this is probably a higher spec than you need, but I'll just go through what I've got anyway. So yeah, we'll be spinning up a lot of containers in Kubernetes, which obviously has an impact on your local hardware, most especially memory, really. So I've got an Intel i7, I've got 32 gig of memory, which is probably way more than you need. In fact, it is definitely way more than you need. It's just what I happen to be running. 16 gig will be absolutely fine. So 16 gig, you should be totally fine. Anything less than 8, I mean really 8 is probably the minimum, the absolute bare minimum, and I think even if you're running 8 gig, you're probably going to struggle a bit with that. So between 8 and 16, I'd recommend 16 to be honest with you. And the hard drive is sort of irrelevant, but I just happen to have a 1 terabyte solid state disk drive. But it's really the memory. Memory is the main thing that you will need. So yes, 16 gig, you should be fine. Now, the other thing I want to call out is we are doing a lot of Kubernetes stuff in this course, so I have produced a free cheat sheet that you can download. It's a nice one-pager that you can refer to, so either on screen or you can print it off, and it has all the Docker and Kubernetes commands that we're going to be using in this course. So it's a nice little one-pager reference guide. It has our Kubernetes application architecture reference on there, so again, you can kind of tick off what we complete as we move through the course, and we also have a Kubernetes object glossary. So again, if you're new to Kubernetes, we cover it all in the course, but again, everything that you see on screen here is on a nice little one-page summary for you to download. So all you have to do is go to .netplaybook.com, that's my blog website, and just register for our mailing list, and we will subscribe to our mailing list, and we'll email you with a download link. And I do want to call out that we never, ever, ever pass on your email address to anybody else. In fact, I hardly even use the mailing list at all. I probably send out an email maybe once a year or something, and I definitely do not pass it on. So just be assured, if you do give us that, it's totally secure and we don't ever pass it on to marketeers or anything like that. Other course resources, the code is available on GitHub for you to download and follow along. There is a lot of code here, there's a lot of scope to make errors, and I've made a few errors as I've made the video, which you will see if you follow along. Don't worry, I do correct them, but it's always nice to have that backup of a code repository so you can refer back to and compare what you've done. In the description of the video, I have put timestamps to all the sections, all the main sections in the course, so it's a very long video, so I don't expect anybody to go through it in one sitting. So the course outline description, in the description, you can jump to each section and come back and revisit at your leisure. And then finally, the course slides, the stuff that we're going through. There's quite a few slides that we're going to go through. I'm not making those available publicly, but they are available to my Patreon supporters. The $5 supporters and above can download the course slideware through my private GitHub repository. So if you're interested in that, maybe check out my Patreon site at the following address. All right, so let's come on to talking about microservices now. We've done enough introductory stuff. So what are they? And rather facetiously, I'm saying, how are they saving the world? Not being totally serious when I say that. So let's look at this idea of a single responsibility principle, which was coined by this chap, Robert C. Martin. And what he's saying is, gather together those things that change for the same reason and separate out those things that change for different reasons. So what did he mean by that? Or what do we mean by that? Well, that really is a nice way to kind of, at a high level, think about microservices. So what are they? They are small, okay? They are built, let's say, by a team that would consume 2 pizzas. That's a way that we often measure team size. So imagine, at the end of the sprint, end of the week, you want to treat your team to pizza. You only need to buy 2 pizzas to satisfy this team. So small team. Or if you want to think about it and how long it would take to build a typical microservice, you're looking at maybe 2 weeks to build. That's what we mean by small, although that is quite a subjective term. They are responsible for doing one thing well. So you kind of have this idea of a microservices application, which will include many, many different services. Each of those services will do one thing and do it really well. Okay, so again, go back to that single responsibility principle. If something's doing one thing, does it really well, it doesn't need to rely too much on the other parts of the system. Although paradoxically, in order for it to be a microservices application, services typically will talk to each other because they need to share data between themselves. But you don't want it doing so much sharing that they're chatting to each other all the time. So that's why breaking down your services into doing one thing and doing it well is really important. They're organizationally aligned. So think of a large organization. The parts of that organization will typically be responsible for running and managing a set of different services, and they have almost exclusive control over those services. So they can change them when they want to, and they can make additions to them, take them down when they need to. And other parts of the organization, they will have their own set of microservices that are aligned to their part of the business. And again, they will need to, or most usually, they do talk to each other. This is really important. So again, we will talk a lot about decoupling and the fact that you don't want services talking huge amounts to each other, but at the same time, again, paradoxically, in order for it to be a full microservices solution, the services typically form part of a distributed whole. So one service doing one thing by itself, never talking to anything else, is that a microservice? Possibly it's not, okay? It really is a true microservice when it does form part of this larger distributed system. And again, this is we've already kind of covered this, self-contained, autonomous. So again, they are responsible for doing one thing. They can stand on their own without being too reliant on other things. All right, so just to help position what microservices are, let's look at the contrasting side of things and look at monoliths for a bit. Now, you might be wondering what a monolith is. So probably the best way to describe it is by reference to an actual system. Now, the system I'm going to describe here is actually an amalgamation of a number of systems that I've worked with or been across at various points in my career. But one thing is definitely, for sure, if you work in a large organization, there's a very, very strong chance that you have a system like this in that organization, in your organization. So this is a sort of example of something that I have come across on my travels. So a large monolithic CRM system that services millions of customers. So it's a really, really super important system. Evolved over many years. So again, it's not something that's been stood up within the last 6 months. It's been around for many, many years in an organization that itself is many, many years old. Built on a single proprietary technology stack. So obviously there'll be different technologies that make up the monolith, but for the most part, it will be built on one platform, one tech stack. And in this case, and in most cases, it will typically be managed by an outsourced partner. So it won't even be managed by the organization itself directly. Most usually, or a lot of the time, systems like this are managed by third parties. So what's wrong with that? Well, this system is very, very difficult to change. It's a huge code base. Making changes even to a small part of it, you have to make sure that it hasn't impacted any other part of the code base. So change cycles are months in duration, and even for big migration projects, if you're maybe migrating from one monolith to another, they can be years and years in duration. But for this particular one I'm thinking about, the change cycle was at least 3 months. Lots of testing, often frequently manual testing to make sure that nothing has broken when you make changes to these systems. So difficult to change and therefore very slow to change. Difficult to scale. Now, what I mean by that is, the CRM platform is a huge system. And let's say, for example, you are going to experience increased orders at certain points of the year, say, near holiday periods or something like that, or, Black Friday sales or something like that. You may want to try and scale the part of the system that just deals with ordering, and all the other parts of that system don't need to necessarily scale as much. But with a monolith, you can't do that. You have to scale the entire system. So quite difficult to scale specific bits of the system. You can scale it, but it means you have to scale absolutely the whole system, which makes it quite inefficient to scale. And then finally, you're locked in. You've got one big, huge platform. It's locked into the technology stack, pretty much. Very, very difficult to change the technology stack. And also, if you're using an outsourcing partner, you're locked in from an intellectual property perspective as well. So this one party knows everything about that platform, which is fine, but you can't then choose another party to manage that system. Well, you can do, but it'd be very, very difficult to do so. So you're kind of locked into that vendor managing this platform. It's not a great situation. So this brings us on to the benefits of microservices when you kind of contrast that with that example monolith. Definitely easier to change and deploy, basically because they're smaller and they are more decoupled. Can be built using different technologies, so you're not locked into the one technology stack. Typically, different teams will build different microservices, and it's really up to them to choose what technology they want to use to build those microservices. So long as they can talk to each other, the services, it doesn't really matter what they're built with. You have increased organizational ownership and alignment. So the CRM system, there'll be many different parts of the business that are relying on that system. And if one part of the business wants to change it, another part of the organization may not want to change it, or they may have their changes that they want to prioritize over the other part of the business. So it becomes this headache of managing priority, managing change, whereas with microservices, typically each part of the business owns their own services, and so they can change them and prioritize their own changes till the heart's content, really. Resilience. So we'll see this with an example in a minute. One service can break, that's fine. The other services will continue to run. Whereas with a monolith, if the monolith goes down, typically the whole thing will go down. So you'll end up with this situation with microservices where parts of the system may be down, but other parts will continue to run. And I've got an example coming up. And scalable. So coming back to this issue of scalability, with a monolith, you can scale it, but you have to scale the entire thing. So it's rather inefficient to do so. With microservices, you can focus and scale out just the services that you need to scale. You don't need to scale everything. So it's much more adaptive to different demand patterns. And they're built to be highly replaceable and swappable. So that's the whole point of them. If you are not happy with a particular service, you can replace it with another service built by the same team or possibly built by a different team. But the whole point is that they can be swapped out. You're not locked in. All right, so let's come on to an example of a relatively simple microservices application that kind of talks to some of the concepts that we've just mentioned. So let's say we have an airline and an airline has decided to go with a microservices architecture. You could split your application up as follows. So you would have could have a flight catalog service. So that's the service that contains all the flights that people can book. And let's say, for example, in this example, it's written in .NET with a SQL Server database. And we have, in this case, one running instance of that service. And it's built by a team, let's say, based in Scotland. We then have a second service. This is the booking service. So let's say, for example, it's built using Ruby on Rails. It has a different type of database, PostgreSQL database. We have one running instance and it's built by a team in the USA. And what you'll see here, which is quite obvious, is that each service has its own data store. So the flight catalog will use its own data store and the booking app will have its own data store. Now, these services will more than likely share information, and that's really what the whole of this course is based around, is how do these services share information that the other one relies upon. But one takeaway is that they do not share the same database. They may share data, they will not share the same database. And it comes back to this whole point that one of these instances can go down, the other one will continue to run pretty much uninterrupted, possibly with some limitations. And then to round out our airline example, we'll have a check-in service. So somebody uses the flight catalog service to browse flights. They will then use the booking service to book a flight. And then finally, at the airport, they will check in, or they can check in online. So they all have different domains. They may be run by different parts of the business. Our check-in service in this case is written in Node. We have one instance and it's using a MongoDB. So again, to labour the point, it has its own data store and it's written by a team in India. So the takeaway from this slide is that separate services written by different teams, they have their own database and they will be somewhat reliant on each other. So for example, you won't be able to check in unless you have access to booking details. And again, the whole point of this course is to understand how we can move data between services, but they are independent. So for example, if the booking service went down, people can still browse and look at the flight catalog. So they can still go online, they can still see what flights are available, they just can't book. And likewise with check-in, people can still go to the airport or they can still check into their flight online. They might not be able to book a new flight, but they can still check in. Or let's say the check-in service goes down, people can still browse flights and they can book flights. They just can't check in. So the point of this is that even though one of the services may go down, the others remain up and certain parts of those operations that they are responsible for will continue to run. Unlike a monolith, where the whole thing goes down, everything goes down. And of course, what we're going to explore in this course is the fact that even if a service does go down, we'll be able to recover them much, much quicker. The other thing is to talk about scaling. So let's say this example airline has a sale on and we have lots of people coming to the website to look at flights and book flights. You can scale out additional instances of those services. And the check-in service, you leave untouched because the number of check-ins probably isn't going to change unless you maybe increase the number of flights. But let's say in this example, the number of flights remain the same, but we have a run on cheap flights that this airline is running. And you can scale up and scale down your instances very, very easily. So that brings us on finally to say, so does that mean everything about microservices is awesome and everything about monoliths is completely terrible? Absolutely not. And on this slide, we have some disadvantages of microservices, or certainly some things to consider when you use microservices versus using a monolith. So microservices are difficult to implement. There's no getting around it, they are difficult to implement. Writing an individual service might be somewhat okay, but designing and building an entire microservices architecture is difficult. When you're starting out, especially with a greenfield site, microservices may not be the best approach because if you don't understand the problem domain, you may spend most of your time just analysing the best way to break down and compose your services, and you may end up just in this analysis paralysis where you end up not building anything and you just keep going round in circles trying to determine what microservices you should be building. So yes, you need strong domain knowledge, and so in a greenfield site that may be difficult. Microservices are distributed. So that's something that people tend to forget about, and when you're running, in a development environment, you're not really taking into account the fact that these things necessarily are running over a network. So you can have services running in different geographies that rely on the network. And of course, the network can fail or it can slow down. And so that's something you really need to take into consideration when building microservices. And paradoxically, we keep going on about this concept of, microservices are totally decoupled. Well, as a paradox, they still need to be coupled to something. A microservice that doesn't talk to anything else is probably not actually a microservice. It's maybe a mini monolith or something like that. So yes, you want to reduce lots of chatty messaging between services, but ultimately, in order for them to function as a microservice architecture, they need to be coupled to something, even if it's just a message bus or the database, or more than likely other services. So the good things about monoliths: simpler to implement, no doubt simpler to implement, at least initially. You still can use CI/CD, daily deploys, you can do small changes. So the example I gave of a monolith, it was a huge beast of a system, and you were unable, just given the history of that application, to have a CI/CD type pipeline, do daily deploys, all that kind of stuff. But you can absolutely do that with a monolithic system, assuming that you build it in the right way to begin with. So one of the advantages of microservices is, you can use an agile approach to deliver them, and that's absolutely true, but it's also true of monoliths. So just because it's a monolith doesn't mean to say that you cannot deploy changes daily for a monolith. You absolutely can, but you have to make some considerations and build that application in a particular way, but it is still absolutely possible. Building a monolith is also a great exercise in familiarizing yourself with the domain. So again, especially if you're like a startup or something like that, and you don't really know your domain that well, and you don't even know if your organization is going to be around next year, spending thousands and thousands of dollars building a microservices application where you don't really know the domain may be absolutely a terrible idea, and you may end up spending half your time, just trying to analyze the problem. Whereas if you just go about and start building a monolith, number one, it's a bit simpler to implement, at least initially, and it also is a great exercise in familiarizing yourself with the problem domain. And so if you're one of the lucky startups that actually does start making money, then that's fine. You can then possibly move to a microservices architecture at that point. But at least if you've taken this approach and gone with a monolith to begin with, you're probably going to get up and running much, much quicker. And also you're going to start to understand your domain. So when you do come to actually implementing microservices, you'll probably compose them in a much more efficient way. And you can still have 2 or 3 big services. So this is kind of like a hybrid type approach, I suppose. You might not have microservices where you've got tens or even hundreds of services. You may end up just having 2 or 3 big, maybe not services, but 2 or 3 big applications that each don't do just one thing, but kind of take care of a bunch of stuff that's kind of similar. So it's a kind of halfway house sort of approach, and that may work well for some people. And generally speaking, monoliths won't be as reliant on the network as a microservices application. They're typically not considered distributed applications, so you do not have the same considerations around network latency or even network being unreliable as you would with a microservices application. All right, so let's come on and take a look at the services that we're going to build in this course. And we have 2 services that we're going to build. Now, our first one is the platform service, and that's what we will refer to as throughout the rest of the course. And it's basically going to function as an asset register for our fictional company. So it'll be used to track all the platforms and systems in our company. Now, we're not building out a full asset register system, just to be upfront with you, but we are going to build our platform service to operate in that way. But that is the idea behind it. And most importantly, it's built by the infrastructure team. So this particular team, they have a strong interest in maintaining a running asset register of all the systems in the organization. All right, so let's come on and take a look at the 2 services that we're going to spend our time building as part of this course, and we have two services that we're going to build. So let's move on to the first one. And this is our platform service. Now, what is the platform service? Well, the idea is that it's basically going to function as a sort of asset register. So it's going to contain all the systems, all the platforms that our fictional company is running. So yes, as it says, they're used to track all the platforms and systems in our company. And it's built, in this case, by one team, the infrastructure team. So may not be called infrastructure team in your organization, but maybe you might call it the operational team or the ops team or even the DevOps team. So that's the team that build it. That's the team that's owning it, and they will more than likely prioritize their changes against it. But it's not just to say that they're the only team that will use it. Yes, of course, they will use it, but it may be used by the technical support team systems. So again, faults are raised. You may want to know what system you are raising a fault against, and the technical support team will more than likely consume data from this service. Engineering team may want access to it for similar reasons. The accounting team, they may need access to it just to understand the assets that we have in the organization and what we need to write down each financial year, all that kind of horrible stuff. And even procurement. The procurement team may be interested in data that this platform service provides when it comes to renewing licensing agreements or signing new contracts, all that kind of stuff. So yes, owned by the one team, built by the one team, but will be used potentially by many other teams. So our second service is the commands service. And what is this? The command service basically is acting as a repository of command line arguments for given platforms. So the idea is it's going to aid in the automation of support processes. So imagine the concept where you may need to restart systems in a particular way, or you may need to understand how to back up databases in a particular way, rather than memorizing reams and reams of different command line snippets for different types of platform. This service is going to contain a repository of all those command line snippets. And so built by the technical support team. So this is the team that's going to build this repository. They're going to run it and support it, and they are going to be the principal users of it. So used by, the technical support team. May also be used by the infrastructure team, may be used by the engineering or development team. They may have an interest in getting access to this as well. Now, one thing that's going to kind of recur through the course is the fact that I have the word platforms on this slide, and that's no accident. The command line service is somewhat reliant on the platform service, and getting that platform's data into the command service is one of the things we're going to focus on as part of this course. But takeaway, two separate services can theoretically or should be able to run completely in isolation of each other, even though there is somewhat of a dependency between the two of them. All right, so let's come on and take a look at our overall solution architecture. So this is kind of the 50,000 foot view of what we're going to build. Now, this does not reference Kubernetes or any Kubernetes type objects just yet. When we come on to doing Kubernetes, I kind of overlay all the kind of Kubernetes concepts on top of this view here. So this one is abstracted away from that, and it's really just the components that we're going to build or use. So with that being said, first service we're going to have is our platform service. It will have its own SQL Server database, and together that kind of forms the entire microservice. It's basically going to be a REST-based API. So the public interface, the interface that our consumers are going to use, is a REST-based API. And yes, this service sits within what we're calling our internal microservices domain. Now we can theoretically access that API directly from externally into our internal microservices domain, and we will do that just while we're developing. But ultimately, we're going to use this concept of an API gateway, which is really going to front up all our services. And so any external requests coming in are going to then get routed internally to our relevant services. And so in this case, you can see our API gateway is routing through to our platform service using its REST API. Then our command service, it's going to have its own unique database just for it. Just for quickness, we're not going to stand up another SQL Server. We're just going to continue to use the in-memory database. But the important point to note is that it's absolutely got its own database. It does not share a database with the platform service or any other services for that matter. And it too is a REST-based API, and it too will make use of the API gateway will route through to our command service. So taking a look at this now, it's all great and everything, but is this really a microservices architecture? To be honest with you, I would argue and say that at this point, looking at the screen at the moment, I would say this isn't really a microservices architecture. Mainly because the platform service and the command service are completely and utterly, totally unaware of each other, which you might say is a good thing, but there's no data sharing between the two in any way at all. They're really just totally separate apps that happen to go through an API gateway. So again, there is a paradox here. You do want to have services decoupled. You do want to have them independent, but at the same time, you don't want them so independent that they don't talk to anything else. That is the paradox. So in order for it to be a microservices application, in my view anyway, there needs to be some degree of data sharing between the two. And that brings us on very nicely to looking a bit more at our command service. So what you can see here is a snippet of what the database may look like. And you can see that we have a list of command line snippets, how to do a particular thing, such as stop a service or restart services or generate migrations. And you'll see that we have those command line snippets. But most importantly, you'll see that our command service does rely on the fact that it needs platform information. So for the majority of this course, what we're really going to be concerned about is trying to understand the best way of getting platform data from our platform service down into our command service. Now, as we've said before, the command service cannot reach into the platform service database. Absolutely cannot do that. One approach possible would be that we kind of couple quite tightly the platform service to the command service. And what I mean by that is, once we create a platform in the platform service, we could theoretically get the platform service to post using HTTP to the API of the command service and say, here's a new platform that I have created. This does create quite a tight coupling between these services though, because the platform service absolutely has to know where the command service sits. And that does kind of create this concept of a coupling. So really what we're going to focus most of our attention on in this course is the idea of using asynchronous messaging via an event bus or a message bus. And so what we're going to do, similar sort of scenario, when we create a new platform in the platform service, we're going to publish an event onto our message bus. Now, all the platform service is aware of at this point is the fact that there is a message bus. It is not aware of the command service, nor does it care that there is one. And in this case, what we're then going to do is we're going to get the command service to subscribe to the message bus and receive those platform published events, and then it will add those platforms to its own database. So this idea of creating data in one service, in this case a platform, and it subsequently making its way down to other services is something that we call eventual consistency. Again, services don't share the same database, but they do need to share the same data. And so the main problem that we're really looking at here is how do we make sure that all these services have all the data that they need and data that may come from other services. So in this case, we're going to use a publisher-subscriber model, synchronous messaging to get that information down into our command service. And again, to labour the point, the platform service does not even know that the command service exists. And again, we're only going to do 2 services as part of this video, but as you can see here, you may have other services that publish other events onto the event bus and subscribe to other events or similar events. And you can see again that the XYZ service has its own database, the ABC service has its own database, so on and so forth. So you have this decoupled architecture, event-driven architecture, which is really what microservices are about. So to round out our solution architecture, we are going to make use of gRPC, and gRPC is used quite a lot in microservices, so for that reason I've included it. And what we're going to use gRPC to do is allow our command service to reach out to our platform service and pull down any platforms that it doesn't already have. But the point to note about gRPC is that it is synchronous, it's not event-driven, and so we are coupling our command service to some extent to our platform service. Okay, so let's move on to taking a look at our service architecture. So again, we'll look at the main components that make up both our services. So we'll start with our models, our internal data representations. We'll have a DB context, which mediates those models down to our persistent layer, in this case SQL Server. We're going to make quite extensive use of data transfer objects, DTOs, which are external representations of our model data, and they're mapped, as you can see there, to our models. And we're also going to make use of a repository pattern, which just abstracts away our DB context implementation. We're going to have our API REST controller, which is I'm calling synchronous in. So HTTP requests coming in, we'll say externally, reach into a repository, pull back any data, and then send back the HTTP response using a DTO. So that's really our external contract going out to our external consumers. We're also going to have a HTTP client, which is, I'm calling here synchronous out, and it's going to make HTTP requests to our, in this case, command service and receive back a response. Now, I'm including this just for completeness, just as an example. We're not making extensive use of this, but we are going to build it out just to demonstrate that particular approach. We're then coming on to the main event, which is to use a message publisher, which is asynchronous out. And so our platform service, yes, is going to publish events onto our event bus, onto our message bus. And then finally, we're going to use gRPC within our platform service as a synchronous in service. And so clients, in this case our commands service, can use gRPC to request platforms back from our platform service. And we're using gRPC to do that. Now, an important point to note, the only external interface here is our controller, our HTTP Web API controller. Everything else that is not denoted by a green line is internal within our microservices domain. And as you can see from the darker coloring on the publisher, it's asynchronous, the other ones are synchronous. So command service architecture, I'll just go through these quickly, it's exactly the same. Again, this is exactly the same. We're going to have a controller, synchronous in, responding to HTTP requests and giving HTTP responses. We're going to have a message subscriber. So this is asynchronous in, so it's going to receive messages from the message bus. And we're going to have a gRPC client, synchronous out. So this command service is going to make requests to our gRPC service in our platforms service. And again, the only external interface here really is our Web API controller, right, REST API controller. And with that, I think we start coding. All right, so I'm going to come over and we're going to start to build our platform service. So I'm just going to start a new Visual Studio Code window, and I think it's probably started it on my other screen. Indeed it has, so let me just pull that over. Rather annoying. Now I've got my screen running at 150% magnification, so hopefully that's large enough for everybody to read clearly what's happening on screen, but at the same time balance that it's not too cramped for writing code. So I might change it if it's not, if it's a bit too cramped, but I think this is going to be okay. So I'm going to bring up the integrated command terminal by doing Control and back quote, and then change into my working directory. Now this will be, chances are something different for you, but for me it's on my D drive and it's season 4 and then it's episode 3. Do a quick directory listing and it's empty. Now we're going to create a few projects in here as our main sort of solution folder, but for the moment let's just work with individual projects. So the first one we are going to set up. Now actually before we do that, let's just do a .NET version, --version, just to check the version of .NET that we have installed, and it's version 5. I would strongly suggest you use version 5 and not 3.1, which probably will work, but you might have to make some tweaks here and there to get it working, so go with version 5. All right, so I just did a CLS to clear the screen, and we're going to do a .NET new. Web API is the template type that we want, and then we give it a name of platform service. And I'll just make sure I've spelt platform and service correctly. Looks like I have, so hit enter. And that will go away and scaffold that up for us. So quick directory listing will confirm that that is the case. So I'm just going to do a code, open this recursively, and I'm going to open this folder up. So platform service. And that will open our project up for us in Visual Studio Code. Now, I'm assuming that you are somewhat familiar with web APIs in .NET. As I say, if you're not, then I would suggest you check out one of my other videos that I've put links in the description below to. We'll just click yes to this, and this will just create a .vs code folder, just so it remembers our settings and so on and so forth. So I'm going to delete the weather forecast class. It's just like a class that's used by the templated project. And I'm also going to come into controllers, and I'm just going to delete the weather forecast controller. Fantastic. And then you should be familiar with the regular anatomy of a web API project. And we've really only got a controllers folder now empty, but don't worry, we will be populating that relatively soon. But the first thing I want to do is really just start to add in our dependencies, our package dependencies that this service will require. So again, I opened up my start menu there. So control and back tick to get the integrated terminal up and running. And I like to leave the platform service CS proj file up and running. So as we add packages, you'll see them being added to this file, just to make sure that we've not made any typographical mistakes. So the first thing I want to add is .NET add package, and the first one is AutoMapper. And I'm actually just going to copy the package name from my notes over here because it's a little bit long-winded. There you go. So it's automapper.extensions.microsoft.dependency injection. And I'll hit enter. I'm sure you don't want to see me typing that in. And you can see it's been added as a package reference to our CS proj file. And then the next one, .NET add package. And again, I will save you from my typing because I'm sure you don't want to see me type out some rather long package names. This one's a bit shorter though. Microsoft Entity Framework Core, which of course our database context class will be using to communicate to initially our in-memory database and then subsequently our SQL Server database. But we do need a few more packages in that space. So I just did upkey, so .NET add package, Microsoft Entity Framework Core design. You need that one as well, and that's just at design time. This does not get included at runtime. And then the last one in the, well actually no, it's not the last one, we got two more to go. So Microsoft Entity Framework Core. We are initially going to use an in-memory database because it's just a lot simpler than connecting it into SQL Server, but we will of course use SQL Server eventually. But yeah, we do need Microsoft Entity Framework Core .in-memory. And then the last one in this kind of Entity Framework Core is of course SQL Server. So Microsoft .entity framework core .SQL Server. And I think that's us good for now. So you can see that there was one other package in there, the swashbuckle. That just gives us an open API spec out the box, which is quite nice. We might take a look at that later if I remember, but for now, we're going to leave it at that. Now we are going to add other packages, but I'm not going to put those in just yet. I'm going to wait till we come to the relevant section and then we'll add those in. I'll just have to make sure that I do remember to do that. So for now, that's good. Our application is scaffolded up. We've included our packages, so now we are going to move on to adding in our model. All right, so back over in our project, we're going to create our first model. Well, in fact, our only model for this service. So in the root of our project, I'm just going to right click and do new folder. And I'm going to call the folder models. Although we're only going to have one of them, doesn't matter, use that naming convention anyway. So right click on the models folder and new file, and the model is going to be called platform.cs. So it's just a plain old C# class. And this is really our internal representation, our application's internal representation of our data. Why am I saying that? Well, we go on to use data transfer objects in a bit, which are basically our external view of our data going out. So models internal, DTO is external. All right, so namespace, which should be platform service, and then we'll do models. All right, and then the name of our class is just a public class is platform. And this is probably going to attempt to autocorrect. No, it didn't. Great. That's it. So it's public class, and then we're going to add some properties to it. So to sort of shortcut writing properties, if you type prop and then tab, and then you can tab through the property that it's created. So yes, this instance, we do want an integer, so tab over, capital ID to give us our model ID, and that will eventually become our primary key down in our database. Next prop, so again prop, tab is this time a string, and it's just going to be called name. I'm only going to do a few properties here. Next property will be another string, and I'm going to call this publisher. Okay. And then the final property, and we're not really going to use this, but I just want to labour the point. I'm going to create another property to make it a string for simplicity, but I'm going to call it cost. Now, while that's a bit of an ambiguous property name, the point here is that for this service, you might want lots of properties that describe the platform. So cost might be how much it costs, or it might be its annual subscription, or it might be a support cost, or it might be the cost to run. And you could add all these in, as well as lots and lots of other properties very specific to this domain, to this microservice. It's a platform service, it's an asset register. You might have loads of attributes in your platform model that you might want to have there. Spoiler alert, we're going to have like platform representations elsewhere in our microservices ecosystem, in our commands service specifically, and it's just not going to be interested in that type of data. So the point I'm making here is, yes, you're going to have this concept of a platform that permeates throughout our system, but different services will have different views on what that actually means for them in terms of the context of what they're trying to achieve. Okay, so a bit of a long-winded way to say that you could have loads of stuff in here that other services just may not be interested in when they come to modeling or representing this type of data. Cool, so let's just save that off. And then the only other thing we want to do, just to help Entity Framework along a little bit, is just decorate these with some annotations. Now, the first one I'm going to use is the key annotation, just to say that this ID is going to be a key in our database. So make sure your cursor is in the offending article. It's got the little red squiggle under it. Make sure your cursor's somewhere in there, and Control and period to get Visual Studio Code to give you some code suggestions. And I'm going to select the first one here using System Component Model Data Annotations, and we'll add that in the top for us. Now, we're going to be doing that control period about 1 million times, well, not 1 million times, but a lot throughout this course. I'm not going to say it again, although I'll probably mention it again, but that's how you get those code suggestions up. Now, just a word of interest. By default, Entity Framework Core would interpret this property as a key. You don't really technically need to specify that it is a key, but I just like to do it just to be a bit more complete. And it also acts as kind of in code documentation, although it's not really documentation. This is similar. This is not actually required because a primary key is of course mandatory, so you don't really need to have the required attribute, but I just like to put that in because, well, I'm maybe a bit weird. And then I'm going to make all these other properties required as well, so they cannot be null. All right. So that's it. It's a very simple class, and you might be going, that's a bit too simple. Believe you me, you don't want it to be any more complex because there's a whole lot of other complexity coming down the line, so we want to keep it relatively straightforward and relatively easy to understand. Cool, so that's our model created. We'll move on to the next section, which is looking at our DB context. All right, so the next thing we want to do is create our DB context. So again, just we'll pay a quick visit to our architecture. So we've created our model, just a platform model. We're now creating our DB context, which effectively maps our models down to our persistent data store. Now, to begin with, we're just using an in-memory database, but we will move to SQL Server eventually. So this is the next thing that we're going to tackle. So back in our project, new folder in the root, and I'm just going to call this data. I'll put a few data related things in here and right click and new file, and we'll call this appdbcontext.cs. And then namespace is just platform service.data. And it's just a public class called appdbcontext. And we're going to inherit from the base DB context class. And it's probably going to try and autocorrect here, but let's see how we go. Yeah, it did. So just go back and take that back out and just say we're inheriting from DB context. So we want to bring in that namespace, so control period, using Microsoft Entity Framework Core. Fantastic. And then we just want to create a constructor that we can, if we need, pass in additional options if and when we need them. So constructor, actually short code for constructor is ctor tab, and then you can just tab through, and we're going to pass in one parameter, which is DB context options of type oh, well, whatever our class happens to be, so DB context. And we'll just call that OPT. And we can get that from base. Okay. And we don't need to put anything in there just yet, but that's our constructor, that we'll use for this. And then most important, well, it's as important, we need to define a database set, a DB set, and which relates to our model. So that's really what's telling our DB context to mediate or mirror our internal model down to the database. So we just specify a property, prop, tab. This time it's of type DB set. And the type of DB set is platform. And we'll complain, so control period, bring in the namespace for our models. We just want to call that platforms, plural, okay? So that's our DB context class set up. Then what we need to do is we need to kind of register it over in startup. So let's do that now. And in our configure services method, we want to add that in here. I'm just going to take these comments out because the code looks busy enough at this level of magnification without additional redundant commentary. So yeah, we're going to put that in configure services, which is where we register all our services. No surprises there. So I'm just going to add that here, services, add DB context. What type of DB context are we going to add? Just the class that was added in the last section. And it probably won't find that, so we'll need to bring that namespace in. Control period using platform service data. Fantastic. And then we'll just specify some options. And we're going to tell it what type of database we are wanting to use. So we're wanting to use in mem database. And I don't think it's finding this. I think we've probably got to bring back, yeah, using Microsoft Entity Framework Core. Let's bring that back. And let me take a new line on this just so you can see that a bit clearer. And then you just give the database a name. It can be anything, it doesn't really matter. I'm just going to call it in mem. So we are using our DB context with an in-memory database. And again, we will move to SQL Server and we'll make some determination in here, a bit of a check to see whether we're using a development environment, which I'll still use the in-memory database, or when we move to production to Kubernetes, then we will use SQL Server. But we can leave that for the moment. We just want to get up and running with our DB context. And that's it for our DB context. So in the next section, what we're going to come on to doing is we are actually going to work with a repository. So we're going to start to set that up in the next section. And really what I want to try and do is get all this blue stuff kind of set up, this data stuff set up before we move on to the more interesting stuff. Not that this isn't interesting, but we get all this wired up and then we can move forward. So repository next. All right, so back over in our project, what I'm going to do is I'm just going to get rid of this terminal for the moment. It gives us a bit more space in our on our screen. And yeah, we're going to create a repository now, and we're going to use the interface concrete class pattern because we will inject our repository through dependency injection in our startup class. But if you don't quite follow that, don't worry, we'll do it step by step anyway. So the first thing we want to do in our data folder yet again is create an interface, and an interface basically just it specifies what type of things, the method signatures effectively that our repository will support, and then any concrete class can come along and implement those interfaces. So yes, over in our data folder, right click, new file, and because we're defining our interface first, we will specify a capital I, and I'm just going to call this platform. There we go, you're just going to do it eventually, platform repo for repository.cs. Not repi. That sounds like it's Latin there, I did it again, repo. All right, I platform repo.cs, okay. And namespace of platform service and data. And it's just a public interface called I platform repo. And then all we do in here is specify this method signatures effectively. So the first one, and if you've done any Entity Framework Core stuff before, you'll realize what this one is for, but basically we need to save any changes that we make. So whenever we add stuff to our DB, through our DB context, adding it or deleting it is not enough. You actually have to save those changes. So we'll need to put something like that in here, which is what that is. And you'll see how that works when we come on to doing the concrete class. And then the first kind of proper signature that I want to define is getting all our platforms. We want to be able to use our API, use our service to retrieve all platforms. So specify it as an enumerable, which we don't have the namespace for. So enumerable of platform, a platform class, or platform service. And we'll just call that get all platforms. We're not going to pass anything in. So quite a simple operation. So bring in using system collections generic for the enumerable, and then we'll bring in the, try that one more time. Using platform service models, there we go. Okay, so this interface should allow us to get all platforms, specifying it as an enumerable. Next one we want to do is just return an individual platform. So not an enumerable this time, just returning a platform. And we'll call this get platform by ID. And this time we will pass something in, which will be the identifier of the platform, the ID of the platform, the unique ID. And then the last one is we want to be able to create a platform. So just make that void. Call it create platform, and we will pass in a platform object into that method, and then we'll have to call save as well when we come on to doing that. But that's basically our interface done. These are the three, or really four, but these are the three things that this interface should provide somebody that's choosing to use this interface. And now what we need to do is we need to build out an implementation class of this interface. So we'll do that now. So again, in data, right click, new file, and we'll just call this platform repo.cs. So over here in namespace, create namespace, we'll call platform service, data, fantastic. And then we just specify it's a public class called platform repo, and it's going to implement platform repo there. Okay, and straight away it will complain because we've not actually implemented any of these methods here. So again, our best friend, put your cursor in there, control and period, and click implement interface. Now it's not clever enough to actually fully implement it. All it does is create these placeholder method definitions, and then you can just see it's just throwing a not implemented exception. So yeah, it doesn't fully implement it, but yeah, it gives us the placeholders that we need, which is good enough. And actually you wouldn't want it to implement it anyway, because generated code is not that great, but this is fine. All right, now before we come on to doing that though, we want to actually create a class constructor, and this is our first use of our first proper use of seeing how dependency injection works. So again, ctor to create a shell constructor, and what it's going to expect to be injected in is an instance of app db context, and we'll just call that context. Okay, so whenever we use platform repo via our interface, when it gets constructed, it's going to expect an app db context to get passed in, and because we have registered our app db context here in our configure services method, that will occur. Okay, so I'm not going to go too much more about that. I would expect you to be somewhat familiar with dependency injection, so I'm not going to explain it further than that. But we'll use it so much throughout the rest of this course that it will definitely become second nature to you. And then to finalize, we actually need to make use of this context that's injected in, so we do that via a private field. And the convention is to typically start these with an underscore. Well, I do anyway, and you'll see it used a lot like that. So basically, whatever's injected in here will get assigned to this. And again, this doesn't exist, so control period. And what you want is this one here, generate read-only field. And I'll put it up here for us, private read-only appdb context. And you'll see this pattern used time and time and time and time and time again throughout the rest of this course. And that's really dependency injection in a nutshell. So we can come on to working with our methods down here. So I'm going to start with the simplest one, and we'll do save changes. So let's just get rid of that for the moment. And all we want to do is return, and we're going to make use of our DB context, and we're going to say save changes on that context. And then this little bit here is really just saying if the result of save changes is greater than 0, then we basically return true back. So we had something that changed. So that's all that is. And we'll call this after any create, update, or delete operation. Any unsafe operation that we have on our data source, we will have to call that to make sure those changes are flushed down to our database. All right, so let's start with this next one, which is getting all platforms. We'll do that one next. And it's really quite simple. Return, again, we'll make use of our injected context. And then on this, you can see that we have our platforms object available, and that is just coming from, that's just this property here. We're just referring to that now. So we're going to return platforms to list. And I think we'll probably have to bring in the link namespace here. Yep. So control period using system link, it puts that in at the top for us. Fantastic. And that's all we need to do for that. We'll come on and do our get platforms by ID, and it's slightly more complex, but not much so. So return context platforms, but this time we're going to use this first or default method to say give us the first instance of a platform, or the default one. And then we're going to specify some criteria using a lambda expression. So we'll say P goes to P, and we're wanting to find the ID of the platform where it's equal to, I'll get rid of that prompt, where it's equal to the ID that we pass in. So quite straightforward. We're basically saying, yeah, return everything from platforms, no, what the first or default item, excuse me, from platforms where the platform ID equals the ID that we passed in. So it's conceivable that we get nothing. It's conceivable we get a null return there, but nonetheless, that's okay. And then finally, well, we've done that one already, haven't we? And then the final one is creating a platform. So first thing we want to do is check to see that we've had some sort of valid object passed in. So we'll just do a fairly simple if plat equals null. Then we don't want to do anything. So actually I probably shouldn't have deleted that throw statement, but we'll just type it in again, throw new argument. Actually puts a slightly different exception, argument null exception, name of plat. Okay, so that just gives us a more descriptive exception, and we'll just bring in that namespace using system. So if platform is null, if it's not been defined and we're trying to create one, then we'll just throw this exception. Otherwise, quite straightforward. Context, platforms, add, and then we just add the platform object that we've been passed in. Fantastic. Now when we come to use this, as I've said before, we'll then need to call save changes to flush that down to the database. And that's it. That's it for our repository, and that's actually it. We're not going to change this now. That's our finalized repository, and that's our finalized app DB context. So the next thing that I want to do, and just before we do our DTOs, is kind of create a little class that's going to prepare our database. So when our app starts up, I want to actually put some data, some mock data into our database, just so that we have some there to work with. And when we come on to using SQL Server, I want to also run what's called migrations to actually create the data structure in the database. With the in-memory database, you don't actually need to run migrations, which is kind of good, but kind of bad. The other thing I will say about the in-memory database that we're using now is that it really is only used for test purposes. It's not a production type database. And of course, because it's in memory, if the service restarts, you'll lose all your data. So it's really, can't stress it enough. Probably should have mentioned it when we were setting up our DB context. It's really just for, it's really not even used much in development environments. It's really just used for testing, really. But we're making use of it here just because it's going to get us up and running much quicker than setting up databases. So we will eventually move to SQL Server though. So yes, anyway, what we want to do next is prepare our database, put some data into it. So we're going to create another little class to do that, and then we'll come on and finish off with our DTOs before we move on to writing up our controller. All right, now actually just before we go on with creating our database preparation, one thing I forgot to do, having created our repository interface and our concrete instance of a repository, one thing I didn't do is actually come over and register those, well, register that for dependency injection, so that when somebody asks for an interface, a repository interface, we give them whatever concrete class we specify. So the way we do that is just over in configure services, and we'll just make use of services again, and we're going to add a scoped service, and we will just say if somebody asks for iPlatform repo, we're going to give them platform repo. Cool. So yes, obviously very important when it comes to using dependency injection, we register our interface and the concrete implementation of it in configure services. So somebody asks for this, we give them this. Fantastic. So let's just save that off. The one thing we've not done so far is build. So let's just bring up our command line and let's just do a .NET build. There's not much to run yet, so we'll just do a build. I mean, it should be okay. We'll run it once we've kind of come to the end of this sort of section of data stuff. So that's all good. So I just want to do that, make sure we're okay to go. So yes, next what we're going to move on to is creating a class to kind of prepare a database with some example data. Okay, so just back over in our project, I'll just close down our startup class and give us a bit more space. And yes, we're going to create our database preparation class. So over in data, just right click, new file, and we're going to call this prepdb.cs. And then we'll begin with a namespace as usual, platform service.data. And this is a public static class with the name of prepdb. Get that round the right way. And yeah, static class, we don't need to create instances of it. And this class is going to have two methods, one public and one private. And the public method is going to set up a database context for us that we can use. Now, this isn't a constructor, this is just a public method. So you might be going, wait a minute, got a couple of questions here. Why aren't we using constructor dependency injection? Great question. Well, we can't because it's a static class, so we can't use constructor dependency injection. And the second question you might have is, why are we using a DB context? Why don't we use the repository that we just created? And that's another great question. So the reason I'm using a DB context in this case is that eventually I'm wanting to use this class to generate migrations in our SQL Server database. And it's just much easier to do that directly on a DB context. All right, and there's a couple of other methods that we're going to use here that I don't really want to build into my repository anyway. This class here is really more for testing. This is not something I would probably push into production. It's really just for us and for this video to help us set up things in our database environment. So that's the two reasons. We can't use constructor dependency injection, and I'm using a DB context mainly because I want to use it eventually to create some migrations. All right. So with that being said, let's create our first, let's create the signature for our first public method. So it's public static void, and I'm going to call this prep population. Now, before we define what we're going to pass into it, if we come over to our startup class, we're going to call this method, this prep population method on this class from startup. So once we've run configure services and then configure starts to get run, we're going to call it in and around here. And what we're going to pass in order for us to be able to use a DB context is this iApplication Builder instance here. We're actually going to pass this through into it, and then we're going to use this to create something called a service scope, which we can then use to create a DB context. So it's a little bit heavy at this stage in the course, and it's slightly off topic, but we have to do it, and I'm just trying to explain it as best I can. So hopefully you'll follow the code. It's not that bad. But let's get on with it. So yeah, we need to pass in an instance of this to this method over here. So let me just code that up now. So iApplication Builder, and we won't have the namespace for this obviously, and we'll just call that app. So what I'll do is I'll just bring in the namespace for that, and I think I probably spelled it wrong. Yeah, there we go. Application Builder. Let's try that again. There we go. Using Microsoft ASP.NET Core Builder. So that's a good tip. You know, if you're doing the control period thing and you don't really see what you want, chances are you've spelt whatever it is wrong. Okay. Fantastic. Now, just before we continue with this, what I'm going to do is I'm going to pop over to our startup class, and I'm going to just call this method, because we've got everything we need now that startup needs in order to know about it, and call it, just so I don't forget. So prep.db, we can access the class directly because it's a static class, and then prep population, and we're just going to pass over app. All right. And that's all we need to do in our startup class, so I'm going to save that off. So back over into prep.db, we will carry on with this. So yeah, as I was saying, we need to create like a service scope in order to derive a DB context. So I'm going to do that via a using statement. So I'm going to create, first of all, a variable called service scope. I'll make that equal to using our app, application services, and then create scope, which I don't think will be available to me just yet, so I'll have to bring in that namespace. So control period, that's the one we want. Microsoft extensions, dependency injection. Fantastic. Now in here, we're actually going to call our next method, our private method, which is the method that's going to do all the seeding of our data and eventually run our migrations. So let's just create the method signature for that. It's a private static void method called seed data, and this is going to expect an app DB context, and we'll just call that context. Okay, fantastic. So where is seed data going to get an app DB context from? Typically, if this was a normal class, it would be via constructor dependency injection. You can't do that, as I've said, so we're going to have to create an instance or call this method, this private method, with an instance of AppDB context from within our first method. So let's do that now. So let's call seed data, and then let's give it the DB context it so desperately desires. And we do that by making reference to the service scope we've just created upstairs, using service provider, and then get service. And any ideas what service we want to get? Of course, AppDB context is what we want to push in there. And don't forget the round brackets at the end. We can close that off with a semicolon. So this public method, that's it, it's basically complete. So now for the remainder of this little section, we're just going to fill out the seed data method that we're going to use to, in this instance, just pass in some data. As we're still using the in-memory database, we don't need to worry about migrations. We just need to pass in some data. We will come back and update this though when we move to SQL Server. All right, fantastic. So let's move into here. Make sure I'm indented in the right place. So the first thing I want to check to see if we have any data in our database relating to platforms at all. So we'll make use of our context, and we will just look at our platforms instance, and that's, if you come back over to AppDB context, we're just referencing this here basically. And then we can use this, we'll probably have to bring in link here, but we can use this any syntax to see. There we go, we're getting autocorrect because we don't have link reference, so let's do that now, using system link, yep. So if the context platforms has anything or doesn't have anything, so make sure you put in the exclamation mark, so it's a not operator. If we don't have anything, then we want to push data in. Okay, otherwise, you do nothing. Now, I'm just putting this else statement in really just to help us with a bit of output, a bit of debugging output. So I'm going to do a console, and I'll bring in the system namespace, so control period using system, console write line, and I'm just going to say we already have data. And that'll come in useful when we actually use SQL Server and data will be persisted. At the moment, most of the time, we're always going to be seeding data at startup because we're using in-memory. And if once we shut something down and restart it, all the data's gone anyway. So for the moment, we're never going to see this. We're only going to see that when we move to using SQL Server, but we'll put it in for the moment. And then likewise up here, I'm just going to put in a console write line, and we'll just say something like seeding data. just so we know that it's kind of working. All right, so now we'll come on to actually putting some data in, and there's another nice method we can call on our platforms object, on our context, so we'll use that now. So context, platforms, and then we can use this method called add range, and it's quite nice because it allows you to add a number of objects at once, which is quite nice. All right, so we're going to create a few new platform objects to pass in and create. And remember, DB context works off of the model, the platform model, nothing to do with DTOs. This is all internal to our platform. So new platform, I'm just going to bring in the namespace. I think I brought in the, used the fully distinguished path, which I don't like. I'd rather bring the namespace in up at the top. So we're going to create, yes, a new platform, and then we simply just specify a new platform. So name equals, first one, let's do .NET, why not? Put a space in there. We'll specify the publisher, which in this case would be Microsoft. And we will then specify the kind of rather ambiguous cost attribute. Let's say it's free. All right, now I want to create a few more. Now, rather than watching me type those out, I'll just go over to my notes, and I'm just going to copy in a couple more. And you can, of course, put in as many as you like here. You don't just need to put in 3 like I'm doing. There we go. In fact, let me get rid of this thing at the side. So Control B to take away the panel, gives us a bit more space. So nothing too controversial. We're just creating a couple other platforms, SQL Server Express and Kubernetes. Don't forget the commas at the end of each line, except for the last one. All right, so that's cool. We've added our products to the database effectively. Do not forget, and I always forget this, do not forget to context, save changes. Because yes, that add range will add stuff to the database, but unless you save the changes, it's not going to go in there. So that's it for the moment. I think that's it for the moment anyway. PrepDB is done. It's going to start up, give us a database context, and add that to our database. So why don't we give that a go now? We did add the call to this method here in startup, so it should be good to go. So Control / to get a command line up. Let's do .NET build, just to build it first. Although when you run it, it builds it. But I like to do the build before the run. I don't know why. .NET run now. So what we should see is this seeding data message. There we go. I think it flashed up on screen. Quite quick though. Yeah, seeding data. So cool. It's realized we don't have any data in our in-memory database and it's seeded the data. Now we can't do anything with that now. We can't access it yet. That's when we come on to our controller. Fantastic. But what we're going to move on to now, just to kind of round out the data section, is look at DTOs. We're going to create some DTOs. We'll do that next. All right, so back over in our application, I'm just going to kill our running server, Control C, and get rid of this terminal. So yeah, we're going to come on now to DTOs. Now, before we start coding, just a little bit of a sense check by reviewing our architecture. So we've created our model, our platform model. We created our DB context. We have an in-memory database. We will move to SQL Server at some point, and we spent some time creating a repository, which our other classes are going to make heavy use of. But just to round out this kind of section, we're going to now move on to DTOs, data transfer objects. And what are data transfer objects? They're basically external representations of our internal models. And you might be going, why do you want to do that? Well, you don't want to expose your internal models to external consumers. Why not? Well, number one, there might be data in your internal models that you don't want to expose, right? The other thing, which is possibly what's as important, is that as soon as you expose your internal models to external consumers via an API, for example, straight away you're creating a contract with them. And if you then want to start changing your internal models, which is entirely conceivable, and you should be able to do that, you may break the contract with your consumers. And you're basically tying your internal implementation to an external contract, which you absolutely do not want to do. So you need to abstract away your internal data from your external data. And that's all DTOs are. Okay, so they're very valuable, and that's what we're going to do next. All right, so back over in our application, make sure you've closed down any running services or anything like that, any running servers. And I'm going to do Control B to bring back up our directory explorer, and I'm just going to close down these windows here just to make it a bit nicer. And we are going to create yet another folder, so right click new folder, and we're going to call this DTOs. And we're going to get our first DTO, new file, and I'm going to call this platform read DTO.cs. Now you might question this and go, what? Don't we just create one DTO? You could, but you're not really going to get the maximum benefit from them. We're going to create quite a few DTOs. In this section, just 2. So the use case is consumers are going to be reading data from us, platform data from our service. So this DTO, the read DTO, is going to be a representation of any data that we want to provide in that context when anybody's reading from us. The other scenario is going to be when somebody wants to create a platform using our service. We're going to provide a view of the data that we expect to be given in that scenario, and it's going to be very slightly different, okay? And that's where the real power of DTOs come in. Anyway, let's get on with this one first. So namespace, platform service, DTOs, and it's just a public class called platform read DTO. It's a very, very, very simple class. And I'm just double checking I'm spelling platform correctly. That looks good. Now what I'm going to do, I'm going to come over to our models folder, into platform, and I'm just going to copy all of our properties. I'm going to paste them in here. Okay. Now I don't mind doing copying and pasting in this instance because I've already typed this code out, and I'm sure you don't want to see me double writing it out again. So let's take a look at these properties. And think to ourselves, when somebody's reading data from us, is it conceivable that we would want to give them the ID of our platform object? Yes, we absolutely would. Would we want to give them the name? Yes, we would. Would we want to give them the publisher? This is where it starts going into, well, it depends what the intention of our API is. In this case, we're going to give it to them. And then cost, the reason I put this property in is really to kind of make the point that this could really be an internal bit of data that we don't ever want to expose. So again, if you didn't want to expose that, you would take it out. But for now, I'm just going to leave it in. May take it out later. We'll see how we go. So for the moment, our read DTO is going to be exactly the same as our platform DTO, and that's fine. But what it does mean is that you can change your internal platform model later, and this could remain exactly the same. Fantastic. All right, so that's all looking good. So we're going to create another DTO now. A little bit more interesting, new file. I'm going to call this platform create DTO.cs. Platform create DTO.cs. All right, great. So start with the namespace as usual. Platform service, DTOs. It's a public class called platform create. Sometimes even too fast for my capabilities here. Platform create DTO. All right, fantastic. Now what I'm going to do, I'm going to come back over here and I'm just going to copy this again. But this time, let's think about the data that we've got here. So someone's going to create, this is for when somebody's going to, this is specifying the data we want when somebody's going to create a platform with us. The first property here, the ID, do we want them to give us the ID? No, in this case we don't, because we take care of that. Our database takes care of that by creating a primary key for us, and that's where the unique key comes from. So when someone's creating a platform with us, we do not want them to supply the ID as part of the body payload, so we take that out, okay? As for the other stuff, we'll leave that in, okay? Because we do want it. Now, let me just pop back over to the platform read DTO, and I actually took out the data annotations there. I should have mentioned that because it's a read DTO, I don't really feel that we need the data annotations in this case, so I'm just taking them out. For the platform create DTO though, I'm going to leave them in because out the box .NET does some nice data validation stuff with our controller actions. So if somebody doesn't supply one of these properties when they call our controller, .NET will go back with a nice pre-formatted error condition for us, which is really nice. So that's why I'm going to leave it in this case. So in order to use them, control period, and we'll bring in this namespace. All right, and that should clear up our errors, and we'll save that off. So yeah, platform read DTO, it's got all the properties. I'm just going to take out this double spacing, it's kind of annoying me. We've got all the properties that we had in our platform model. We're not using data annotations, but that's okay. And then our platform create, slightly different shape to it. We don't require the ID, but we are using data annotations. Fantastic. So that's our 2 DTOs done for this point in time. Now, at this stage, we've got our model, our platform model, and we have our 2 DTOs, but they're just separate classes. They don't know about each other. There's no way we can map at this point to them, but that's what we're going to do next. And we're going to use a tool called AutoMapper to allow us to map from one to the other. So we'll do that next. All right, so moving on to AutoMapper now, let's just clear down our development environment. And there's a few bits of setup required for AutoMapper. The first thing we should have already done, so over in your CSproj file, just double check that you have this package reference included at the top for AutoMapper. And if not, please add it, otherwise the next bit's not going to work. The next thing we need to do is register AutoMapper for dependency injection. So over in Startup, in our configure services method, we're going to do that here. So making use of our services collection once again, there we are, add AutoMapper at the top. And yeah, that should become a relatively familiar pattern that we're using. You can see it's complaining here because we do actually need to provide a little bit of extra detail inside the parentheses. So add domain, app domain, my apologies, current domain, and then get assemblies, and don't forget the parenthesis at the end there. And we'll save that off. So that's AutoMapper now registered in a dependency injection container, so we can use it throughout the rest of our application. Now the final bit of this section is to create what's called a profile. So again, we've got our DTOs, we've got our models, they are not in any way mapped together, and we do that via a profile. So in the root of our project, right click, new folder, we're going to create a folder called profiles. And into that we're going to create a single class called platforms profile. So new file, platforms profile.cs. Okay, and then the usual setup, the namespace of platform service, and this time it's profile. Profiles plural, and curly brackets, and then it's just a regular old class, so public class platforms profile. And we're going to inherit from an AutoMapper class called profile. Okay, now this has tripped me up a few times. Our folder is called profiles, our namespace is profiles plural, this class is profile singular. Okay, it's tripped me up a few times and caused me a few issues, so just make sure you get that correct and bring in the right namespace using AutoMapper. Fantastic, so that's our shell of our class setup. Now, where we create our mappings is actually in the class constructor. So just CTOR to do the shortcut for platforms profile, and tab across, and we just take out the parameters. We don't need any in there. So this is our class constructor, and it's in here that we create our mappings. So let's create our first map, and I'll talk you through about exactly what is happening. And before I do that, let me just do a little annotation, source to target. All right, so we use something called create map, and we specify the source. So think about a scenario where somebody is using our service to read data, consume data from us. Ultimately, that data, the source of it, is in our database. It becomes a model. Well, it is a model, a platform model. That's the source object, and we're going to then map that model to a platform read DTO and give the consumer the read DTO. So the source is the model, platform model, and the target is the read DTO. That's what the mapping is. Now again, if this is a little bit abstract, when we come on to writing our controller, it will become a lot more obvious when we actually start putting it into practice. But for now, let's create our mapping. So platform, so this is our model, is the source. And let me just bring in the namespace for that before it starts, autocorrect starts driving me mad. So using platform service models, and then our target is platform read DTO. Close off the angular brackets and end with a parenthesis and a semicolon, and we'll just bring in that namespace. So again, just to reiterate, this is servicing our reading scenario. So the source of our data is our platform model, and the target is our platform read DTO. Now, a couple of important points here. Because our platform class and our platform read DTO have properties that are named exactly the same thing, and that's the way we want to map them, we don't need to tell AutoMapper anything else. Hence the name AutoMapper, it does it for us, which is brilliant. When we move through the course, we're going to be creating other classes and other entities where that's not straightforward, and we have to then explicitly tell AutoMapper how to map or not to map between properties, but we don't need to do that yet. The second point is here that we've created a mapping with a source of a platform model to a target of a platform read DTO. Brilliant. If you then had another scenario where you needed the source to be a platform read DTO and the target to be a platform, you have to explicitly add that here. Just because we've created a mapping one way from those two objects doesn't mean that there's an implicit mapping the other way. You've got to explicitly add that, okay? Just those 2 points are pretty important. So just before we finish off, we'll create our last mapping, and this one is for the creation scenario. So again, in this instance, the source of the data is a platform create DTO, because that is what our consumers are giving to us. That is the source of the data, and the target for that ultimately is going to be the creation of a model down in our database, a platform model in our database. So the source is a platform create DTO, and the target is a platform model. Okay, so create map once again, and our source this time is a platform create DTO, and the target is a platform model. Make sure we get that correct. All right, and that's it for now. We will add more mappings in here with some rules as well, actually, but for now, that's all we need to service our current scenarios. So save that off, and the last thing I want to do, just before we move on to working with controllers, is just do a bit of a .NET run, just to make sure everything's running up and building okay. And if it is, we can move on to the next section. And it looks good, so let's move on to controllers. All right, so moving on to our controller now, I'm just going to stop our server from running. I'm going to kill the running terminal. And as usual, I'm going to clear down our previous work that we're doing just to make it look a little bit cleaner. All right, so we already have a controllers folder from when we scaffolded up the application, so we obviously don't need to create that. But right click on that, new file, and we're going to create a file called platforms controller. .cs, it's obviously a CS file. Fantastic. And then as usual, we define the namespace of platform service controllers. And then it's just a public class called platforms controller. We're actually going to inherit from something called controller base, which is really a base controller class that's really used for APIs as opposed to full-blown MVC web applications. So controller base. And we will have to bring in namespace, so control period, Microsoft ASP.NET Core MVC controller base. Oh, I selected the wrong option there. I want to, oh, I did it again. Get it right this time. Using, here we go. My eyes were a bit crossed there. Oh, there we go. So we add the using statement at the top, that's what we want. Otherwise it's going to get way too busy. All right, so we're going to create a constructor, so CTOR, tab. And into this, we are going to work with our repository, and we're going to eventually work with AutoMapper. So let's get going with that. So the first thing we're going to inject in is our platform repository. So what are we asking for? We're asking for an I platform repo. I'll just check that's what we called it. I know we just created it not so long ago, but I just want to make sure I'm giving it the right name. So we're creating one of these, and that will be injected in. And we'll just call that repository. And then we're also going to request an instance of mapper, iMapper, which is our AutoMapper stuff, and we'll just call that mapper. And we'll need to bring in the namespaces for both of these. So using AutoMapper and using, I think I might have, yep, there we are, spelt it wrong, platform, not platform, there we go. So try that again, that's better, okay. Now, as usual, what we want to do is these two parameters are being injected. We want to assign them to private fields, usually denoted by an underscore. So we'll assign repository to underscore repository. There we go. And likewise for mapper. And we'll use these private fields inside our class. And of course they don't exist yet, so control period, and we want to generate a read-only field for each of them. And you can see they are added at the top here. Now this is the kind of very, very standard constructor dependency injection pattern that you're going to see lots and lots throughout this course. Constructor for a class will pass in a number of parameters, and then we'll assign them to private fields, private read-only fields that we then use within that class. Fantastic. Now the other thing we want to do is we want to actually decorate our class with a couple of attributes. The first one is API controller, and that gives us a lot of out-the-box functionality relating to API controllers, and I'll call those out as and when we come on to them, but it's mainly around passing through data via our actions and stuff like that, and yeah, sort of default behaviors that most web APIs will want to adhere to. So it saves us a bit of work. And then we want to also define our route, okay? And this is basically where we can find this API and then subsequent actions. So square brackets, route, open round brackets, and we're going to specify API / and then you can either specify explicitly the name of your controller, so for example platforms, or you can use this kind of wildcard approach where you can just put in square brackets controller, and that will take this portion of the controller's name, everything aside from the word controller, and basically put it in here. So you get the same result. So this route to this controller will be API / platforms. Okay, up to you which way you want to do it. I've seen it being used both ways, either using this way or just actually hard coding it, up to you. All right, fantastic. So now we want to come on to our first action, and in doing this first action, we can actually then test to see whether everything we've done so far has actually worked. So we're going to do an action that just gets all the platforms that have been added to our backend database. So public action result, it's of type IEnumerable. We're going to have to bring in that namespace, and it's an enumeration of, what is it? Enumeration of platform read DTOs. Okay, and let me just finish this method signature, and I'll just take you through exactly what we're doing here, just in case it doesn't make sense. And we'll call it get platforms. Okay, so we're not passing anything in, we're not passing in an ID in or anything like that. And yeah, that looks okay. And we're going to decorate it with a verb HTTP get. There we go. So let's save that off. Now, I think this, I'm surprised, I think I've made a mistake here. We just put this other bracket in and then I'll probably get some complaints. Just finish that off. I'm surprised it's not, there we go. It's not complaining, it's complaining now, thankfully, about the fact that we didn't have IEnumerable or platform read DTO namespaces at the top. So let's bring those in. So control period, systems collections generic, and then platform read DTO. There we go. So basically what this is saying is when you call this action, and it's going to be get action at this route, API platforms, we're going to return an enumeration of our platform read DTO. Not our platform entity, not our platform model, but our platform read DTO, because we've said previously, whenever we're sending data out, we want to send over the read DTO representation of our data. So that's why we're doing that. And then from there, it's actually relatively simple. And we're going to get to a point where we're almost ready to actually see that we've not made any mistakes throughout this whole build process to date. So just to help me debug if it's, if we have any issues, I'm just going to put in a console write line. I have to bring in the system namespace, so control period using system. And I'm just going to say getting platforms. And hopefully we get some platforms, but we will see. All right. So we want to now make use of our repository to actually go into a repository and pull back the platforms that we want. So I'm going to create a variable that will contain the return result set from our repository method. So platform items, and this is going to be an enumeration of platform models that our repository turns back. So we'll make that equal to, and we'll make use of our repository, and then we'll have a look, and we want to get all platforms, and we'll just do that. So that will go into our repository class. Let's come over here. It's going to use this get all platforms signature here, and then in our concrete implementation, it reaches in to our DB context and returns us a list of platform objects. Okay, so we have platform objects in here, but we want to return platform read DTOs. So this is where AutoMapper comes in. We're going to map our models to our read DTOs and return that back. And that might sound rather complex, but it's not really, thanks to AutoMapper. So we're just going to do a return. Okay, so HTTP 200 result, and then we're going to make use of mapper, our injected mapper object. So it's mapper, map, and what are we going to map to? We're going to map to an I enumerable of what? Let me just see if I can get rid of this thing, it's a bit annoying. An I enumerable of platform read DTOs. There we go. And what are we mapping from? So this is what we're mapping to. We're going to map to an enumeration of platform read DTOs. What are we mapping from? We're going to map from this collection here of models. All right, and that should be enough to basically get us at the result that we want. So if we just come back to our profiles and we have a look in here, basically that is going to be making use of this mapping construct here. Now, even though we're using an enumeration, doesn't matter. It's smart enough to know that enumeration or single objects, it will still work okay. So again, AutoMapper, very, very cool thing. So let's save that off. Let's do a control backtick and let's do a .NET run. And hopefully everything should be wired up correctly. I don't think I need to do anything with the platforms control. If we come back over, before we test this, we come back over to the startup class. Let me just move this down. Our controllers have already been added into configure services anyway, so everything should be wired up correctly, and our endpoints are all wired up down here in configure. You can see here we have our controllers mapped through, so should be okay. So the way I'm going to test it, I'm using a tool called Insomnia. If you want to use a web browser or you want to use Postman, Postman's obviously very popular, go for it, doesn't really matter. I like Insomnia because the interface is a little bit cleaner. It's just nicer for making videos. So I've got an empty environment here, and you can download Postman free off the internet. I'll put a link down below. I've got an empty environment, so what I'm going to do, because we're going to do a lot of testing throughout this, believe me, we're going to do a lot of testing in a lot of different environments. So I'm going to create a new folder, and I'm just going to call it local dev. So that's a local development environment, and I'm going to put all my requests for local development in here. And then I'm going to create another folder, and I'm going to call it platform service, because we're going to be testing a platform service and a few other things as well. So local dev platform service, and then we're just going to create a request, new request. I'm just going to go get all platforms. You can obviously call this anything you like, it's just a label really, and it's a get request, so create that. And where are we going to get our stuff from? Well, we're going to, if we come back over to our running application, scroll up a little bit, you'll see that our application is listening on localhost 5001 for HTTPS and 5000 for HTTP. Now, in this video, I'm actually not going to work a lot with HTTPS, which is not something I would usually do, but for various reasons, more especially when we come to Kubernetes, it becomes very, very complex, and it's going to kind of distract us from the core of what we're focusing on. So for the most part, I'm going to be hitting the HTTP endpoints rather than HTTPS. Now that's something I might tidy up in future videos, but for the moment I don't really feel it's too much of an inhibitor, especially not when we come to running things in Kubernetes. But it does come back to haunt us a little bit later on in the video when we come to using gRPC, but we'll cover that off when we come to it. So just wanted to call that out. Yeah, running on localhost 5000, 5001. For the most part in this video, we're going to just be working with HTTP to keep it simple. Otherwise we start going down some rabbit holes. So let me just copy that in fact, and I'll just paste that in and put that in over here. And then we want to put our route in, so it's API platforms, okay? So get request, here's our base URL, and then the route to our action. It's API platforms, which should look familiar to you. If we come back over here, it's basically what we specified up here at our class level. If I can find it. No, that's looking in the wrong looking startup. In our platforms controller, we come over here to our class. So our class level, this is our class level route, API platforms. And then we've specified a get. And so the method signature that we're calling from Insomnia will match this method signature here. There's no attributes being passed in or anything like that. So we should get a result back. So let's hit send. And indeed we do. So there we go. We get 200 response back, and we get our 3 platforms returned, which should look quite familiar. These are the platforms that were injected into our in-memory database. So that's awesome. We're on the right track. So all we've got to do now is just finish off our last 2 controller actions, and then we're ready to move on to some of the more interesting stuff. All right, cool. So let's come on to finish off our controller. We'll finish it off for this section. We are going to add a lot more into it going through the course, but for now we're going to, just finish off the basics and get our other 2 action results in place. So if, like me, your server's still running, just Control-C to take that down and get rid of the terminal. Don't need startup for the moment, and we're just going to work exclusively within our platforms controller class now. So what I'm going to do is I'm going to get rid of the sidebar, and I just pressed Control and B just to get rid of that, and you can toggle that on and off. We're not going to be moving around any of our files for this last section. We're just going to be working completely in here, so we can give ourselves a bit more breathing room and see exactly what's going on. So the next action I'm going to add in is going to be very similar to this, but this time we're going to request just one platform using an ID. So let's come on and get on and do that. So again, public action result. What are we returning? Rather than an IEnumerable, we're just returning a single platform. Read DTO. That's all. And I'm just going to call that get platform by ID. And then we are going to expect a parameter this time of type integer, and we're going to pass in an ID. Now, when I was talking about this API controller giving us some out-the-box behaviors, this is kind of what I'm talking about here. By defining this ID as part of an input parameter to this action result, basically that will be interpreted automatically when we come over to testing it, and we pass in /2 to relate to one of the IDs of the platforms. This route will basically be automatically interpreted by this to map to that. Okay, it's kind of nice. You can explicitly tell what you're mapping through from your requests, but in this instance, it's all doing this kind of stuff out the box for us. But of course, we do have to specify that it's a HTTP GET. Okay, and then it's actually very similar to this here. So the first thing we're going to do is declare a variable to hold our results. I'm going to call it platform item, singular this time, because we're just looking for an individual item. And again, we'll make use of our repository class, and we did create a method in here called getPlatformsById. Fantastic. And what do we want to pass into it? We want to pass into the value that's been passed in through our URL. Okay, so we're going to attempt to get whatever was passed in. Now, as per sort of REST best practices, if you try to locate a resource, an individual resource, as we're trying to do here, and it's not found, you should return a 404 not found HTTP result set back. Okay, so that's what we're going to do next, or that's the kind of the check we're going to make. So if platform item doesn't equal null, then we have something, that's good, and we're going to return it back. So we'll return it back with an OK. And we're going to do something very, very similar as we did up here. In fact, almost identical. We just don't need to specify that it's enumeration. But let's type out anyway, because it's good practice to get across this stuff, because we're going to use automapper quite a lot. So mapper, map, what we're mapping to. Instead of an enumeration of platform read DTOs, we're just mapping to a singular platform read DTO. And what's our source? It's this platform item. And that's it. Nice and straightforward. So if the platform item returned is not null, great, we do that. Otherwise, we're going to return not found result, and that will return a HTTP 404 for us. Fantastic. So let's save that off, bring up our command lines, do a .NET run, And remember, doing a .NET run also does a build for us as well, as you can see there. But I don't know why, I sometimes still like to run a separate build and then do a run. I don't know why, it's just my weird way of thinking. So let's run this one again. Let's take out the 2 and just make sure it's still working. There's no reason why it wouldn't be. Well, it isn't working. What have we done wrong? You've done something wrong here. Let's find out what we've done wrong. And we'll just scroll down a little bit. The request match multiple endpoints. Oh, I know what I've done wrong. So this is actually a really good example of, yeah, something that we forgot. Well, I forgot to put in. You can see here we've got 2 HTTP GET requests, and it actually wasn't intelligent enough to, yeah, I forgot a really important thing. We actually have to specify an additional route in here, because otherwise what that error is saying is we've got 2 HTTP GET requests, which it interprets as being completely identical. It doesn't even get down to the method signature here, even though the method signatures are different. So bit of an omission there. So let me just rectify that. So within our HTTP declaration, let me just do open brackets. And what we're basically doing is we're specifying effectively a route, part of the route that we're looking for. So the way you do that is string, double quotes, curly brackets, ID. So we're saying we are expecting, as part of this GET request, an ID. And as part of that, that is then mapped into this. Yeah, that's my bad. You really forgot to mention that. So yeah, as part of this route here, if we do this, 23 for example, it's going to match this route here. If we take this out, then it's going to match this route here. And it was getting confused because we had no point of differentiation. And where API controller comes in is it automatically maps this value into here. There you go. Early in the morning for me here, I'm not quite woken up yet. Now, the other thing we're actually going to do while we're doing this, I'm actually going to give this a name, and you'll see how this comes into play in the next short while. And I'm just going to give it exactly the same name as the method signature name. Okay, and we actually make use of this a bit later on in our next action result. Okay, cool, there we go. So that should be okay now. So let me run that up again, Control C, and run it up again. And let's see how we're going. So let's come back to Insomnia and let's just run our old request. There we go, back to normal, that's cool. And then we're going to create a new request explicitly for get a individual platform. Okay, there we go. And what I might do is I might just copy this over, and I'm going to paste that in here. And let's have a look at our result set over here. So you can see the in-memory database has automatically added IDs for us. Fantastic. So let's see if we can pull back Kubernetes, since we're going to be working with that next, and put in 3. And indeed it does, it pulls back the individual platform for us, which is all good. Now if we put in some ID that doesn't exist, we'll get a 404 not found, which is exactly what we want, and that kind of adheres to our REST kind of standard practices. Fantastic. Okay, good. So I'm actually quite glad I had that error, honestly I am, because it kind of helps you understand how things work. And that's a really good point. When you make mistakes and when things don't work, that is actually, for me personally, that's when I learn stuff. If everything just goes totally smoothly all the way through, you're going to learn stuff, but not as much as when things go wrong. Okay, so this is a long course. I'm just going to call this out here. This is a long video. You're going to make mistakes. I guarantee it. I guarantee you're going to make typos here. You're going to forget to put things in there and things are not going to work. Don't stress out about that. The code is available on GitHub, and you can, if you want to, you can just kind of overlay that on what you're doing. But what I would suggest you do is try and fix it, because in trying to fix it, you're going to learn a lot more than just listening to me talking and going through the video. All right. So rant over. We're going to move on to our last action result, which is creating a platform using our controller. And then we're going to move on to a bit of Docker and then Kubernetes. All right, so let's come on to creating our third and final controller action in our platform's controller. And it's this controller that we're going to use to create platforms in our backend database. And it's this controller that's going to be the one that we're going to return to and do a lot more work in terms of triggering messaging to other services. So we're not done with this one fully yet, but we're going to get it into a state where we're creating platforms and then we're going to move on to something else, but we will return. So before we do that, let's just do a Control-C to kill the running server, get rid of this, and then we'll move down and we'll create our final action. So again, public action result. And what we're going to return back, we're actually going to return back a platform read DTO. So when you create a platform using the service, part of the REST spec is that you should pass back that resource once it's been created. And so anytime, again, about something like a cracked record here, anytime you're returning data back, we're going to use the read DTO. So there we go. Platform read DTO is what we're returning back. We're going to call this method create platform. And what we're going to expect as an input, any ideas? We're going to expect a platform create DTO. There we go. And we'll call it platform. I'll tab that through. So just to go over that again, we're going to return back a platform read DTO, assuming we create one. And what we're passing in a platform create DTO, and that's the DTO we created explicitly for creating platforms. And the only difference really between these two at this point in time is the create DTO doesn't have an ID because our database creates that for us. All right, fantastic. So let me just do our curly brackets and let's make sure this time we specify the correct, we decorate this with the correct route. So it's going to be a HTTP post this time. And that is all we need to do actually in this occasion, because when we are creating or posting a new platform, we don't actually have to specify an ID. If we were doing an update or something, we would have to do something very similar like we did up here and actually specify that we're expecting like a resource ID in here. But for creating, we're just saying it's a post request. And looking across our entire controller, all of our method signatures are now unique. So this is just a HTTP GET, this is a HTTP GET with an ID, and this is a HTTP POST. So the first thing I want to do is actually make use of AutoMapper. So we're getting passed in a platform create DTO, but our repository works with models, it doesn't work with DTOs. So we're going to have to map our create DTO to a temporary model object that we'll then use to pass into our repository. So let's do that first. So new variable, I'm going to call it platform model, and that's going to be equal to mapper, map. And what are we mapping to? We're mapping to a platform object, a platform class, really, not an object. Okay, I'll bring in the namespace for that because I don't think we have that yet, using platform services models, okay. And what are we mapping from? What's our source of our data? Well, it's this here. It's our platform create DTO that was passed in. I'll just put that in here, okay? And we'll round that off with a semicolon. And again, coming back to our API controller decoration here, you're going to probably ask, where is this coming from? Well, we're ultimately, when we come to testing it, we're going to place it in the body of our request. And again, by using this API controller decoration attribute here, this action will kind of look initially to the body request of the request that comes in, and it will just put whatever object it has into here by default. Now you can override that with more explicit behaviors, but again, the default behavior is fine for our purposes. Okay, so we've got a platform model now, hopefully, if our mapper has worked correctly. And if I just do a Control B to bring up my directory listing here and come back into our profiles, you'll see that this is the mapping that's kicking into play. We're taking a platform create DTO as the source, which makes sense, and we're mapping it to a platform. All right, so we're making use of that second AutoMapper mapping here. And then it's quite simple actually. We then make use of our repository and we will do a create platform. And what does that expect? It expects a model. And so we're going to pass in platform model, like so. Fantastic. Now, one thing that we obviously always need to do whenever you make a change or anything like that, we'll need to go back to our repository and we'll need to save changes as well. If you don't do that, if you leave that out, you will have nothing created in the database. So now what we want to do is we want to pass back our successful result if we have one. So in this case, a platform read DTO. As per REST kind of best practices, whenever you create a resource, you should return a HTTP 201 along with the resource that was created and also a URI to that resource, a location to that resource as well. So we're going to do all that in the next few lines of code. But the first thing we need to do then is we need to somehow get a platform read DTO. And so what we're going to do is we're going to use AutoMapper once again, and we're going to map from our model that we've just created back to a read DTO. Okay, so we'll do var platform read DTO equals underscore mapper. What we're mapping to, oh, we've got map, and what we're mapping to, we're mapping to a platform read DTO. Make sure you get these right. I've got these wrong on occasions and mapped to the wrong objects, and it's caused me some problems down the line, but there you go. That's all part of learning. So that's what we're mapping to. What are we mapping from? We're going to map from platform model. Okay. Just get rid of that space there. Okay, so platform create came in, we mapped it to a model, we put our model into our database, and now we're going to return back the platform read DTO version of that. Now this might all seem a little bit long-winded to you. I've had some feedback, people saying they don't like this kind of decoupling to this extent. Well, that's okay. Personally, I still think this is absolutely the right way you should be doing this, okay? You shouldn't be passing back models directly over the wire. I definitely don't think you should be doing that. So what we want to do next then is we've got a platform read DTO, we want to return it back with a HTTP 201 to our requester. Now this line of code coming up is probably the one that I get the most comments about, going this doesn't make sense, and it's a little bit convoluted, and the Microsoft documentation isn't that great. So I'm going to type it out, and then I'm going to go through and try and explain it, what it's actually doing. It's not really that complicated, but it's a little bit convoluted, and it's not really that intuitive, to be honest with you. Anyway, let's get going. So we're going to return, and we're going to use something called created at route. And so what this effectively does, it returns a HTTP 201 with a route as part of that return. So the first parameter that we're going to pass in is actually the name of basically the route where we can get to our resource. So name of, open brackets, and where is this resource residing? How do we get to that resource? Well, that is why up here we gave this action a name, because this basically is the resource URI. Whenever we create this resource, you can actually then get to it using this action result. So we're going to supply this name, okay, to this here. So this is basically, this first bit is saying this is the route where you can actually then get this created resource, okay? And then we're going to actually basically return back the resource itself. And this is, again, this is, I'm going to get rid of this Control B to get rid of that and give us a bit more room. Again, this is a little bit kind of not that nice really, but let me just type it out anyway. So new, curly brackets, ID equals platform read DTO, ID, so this is getting our ID, and then we're actually returning back the platform read DTO as well. And I think I've spelled that wrong, there we go, all right. So basically, we're going to return a 201, we're going to give the route, which is basically this thing here, and then we're effectively generating a new ID, which is basically the resource ID, and then we're passing back the body payload in the response as well. All right, so let's save that off. I think that's all looking okay. Let's do a control backtick. Let's do a .NET run to run that up. And let's wait, that looks okay. And let's come back over to Insomnia, and I'm going to create another request, new request, and this time it's a post request. And we're going to be expecting some JSON as the body. We're going to pass in a create DTO JSON payload, and we'll call that create platform. Fantastic. Now the URI is actually going to be exactly the same as this. Different verb, but same URI, so let's just put that in here. But we are going to supply a JSON body. Now what I'm going to do is I'm going to come over to, let's pick this one here. No, let's pick this one here because I want to get an example payload, and I'm just going to copy one object, okay, just so we have you don't have to bother typing it out, and we have the correct format. So I'm copying one object, curly braces to curly braces, and I'm going to paste that in here. Now, let's come back, before I do anything with that, let's come back and do a Control B. Can I do a Control B if we've got the thing running? We can. And we come back to our DTOs. And let's just take a quick look at our platform create DTO. So what we're expecting to get passed in here is a name, a publisher, and a cost. Okay, no ID. So come back over here and back into Insomnia. We'll take this out. Okay, we don't need that as part of our create payload. There's no ID in here, obviously, because we don't have one yet, but we do need these 3 attributes here. So let's create a new platform. Let's create Docker, because we're going to be moving on to that next. Who publishes Docker? I'm just going to put Docker. I think that's probably right. Might not be that. And the cost is free. So let's send that over. And there we go. We get a 201 created, and we get our resource passed back. And you can see we've got a new ID of 4. If you look over our headers, most importantly, you can see we have a location. And actually it is the URI that we can use to retrieve that resource. And again, that's a really important part of the REST specification. And that was achieved by using, let me come back over to our controller, using this created at route methodology here. Okay, that's what that really gives you. Although it's a bit of a not particularly nice construct, that's what that is basically doing. So that is all looking pretty good. The last thing I'm going to do is actually copy this URI, just to check it, and I'm going to paste it into here, into our individual platform. Just check that it works. There we go, 200 OK, and it's returned the right thing. And finally, if we just retrieve all our platforms now, you'll see that we have Docker in there now. Fantastic. So that's basically just a fairly standard, straightforward .NET Core web, I have to stop saying core .NET Web API now, but it's going to form the basis of our platform service going forward, and we're going to add a lot more interesting stuff into it. Cool, so we'll park that there for now, and the next thing we're going to move on to is a bit of a review of Docker. We're going to Dockerize this, run it in a container, before then moving on to possibly the main event, which is getting all this into Kubernetes. All right, so time for a quick review of Docker. Now, we cover everything that you need to know about Docker in this video, but if you want a bit more detail, maybe check out one of my other videos. But let's take a look and do a quick review. So what is Docker? Well, as it says on screen, Docker is a containerization platform, meaning that it enables you to package your applications, in our case, our platform service, into something called an image, and then run those images as containers on any platform that can run Docker. So what does that mean? Well, basically what Docker allows you to do many things, but one of the problems it helps you solve is this idea that you might be running something you develop on your machine and it works brilliant, but then when you come to deploy it onto some other environment, it doesn't work and there's missing dependencies and all that kind of stuff. So what Docker does is it kind of removes that problem by allowing you to package something using Docker into an image. And once you have that image, you can be fairly sure that you can take that image and place it onto anything else that's running Docker and run that image up as a container, and you can be fairly sure it's going to work okay. So it allows for this kind of transferability and this easy deployability of applications, okay? And it's really referred to, or really could be thought of, as application virtualization, which is a nice segue onto the next slide. So what I want to do here is just call out the differences between running a plain old server or PC, running an operating system and running applications, versus virtual machines versus containers. All right, so in the first instance, you've got a PC or a server, it's running an operating system, it's a physical machine, and you just run your applications on that operating system. Fairly straightforward. We then have a virtual machine setup, which is basically operating system virtualization. And in this case, you'll have your host operating system. You'll then have some kind of hypervisor, which will then allow you to run entire virtual machines on that hypervisor, which then have an entire operating system all of their own. So in days gone by, I've run things like VMware or VirtualBox to run a Linux virtual machine on top of my Windows host system. Okay, now that's a perfectly acceptable use case, and virtual machines are still very much used today. Where Docker comes into play And again, this is a very simplified diagram. There's actually more going on here, and there are actually virtual machines involved, but I've taken that away because it was going to complicate the point I'm trying to make. With Docker, or with any containerization platform for that matter, you have your host operating system, you have, in this case, Docker, and then you have your containers running on top of Docker as applications. There's no full operating system involved. Each of these containers has their own view of the host operating system. They don't run on an entire dedicated OS of their own, so they're much more lightweight and much more efficient. But you still get a lot of the benefits with virtual machines in that one of your containers can crash and die or do something terrible. Your other containers are unaffected, okay? So quite a very nice concept and platform, and very much one that lends itself very well to microservices. So I'm sure you're probably starting to think about, okay, you're running up lots of services. It's probably analogous in some way to a running container. And then you can do all sorts of things like scale out your containers horizontally, so you can have multiple instances of the same application running as multiple containers to allow you to deal with extra demand and all that kind of stuff. And we'll do this a bit later. But for now, we're just focusing on plain old Docker. So that's all great and everything, but how do we get our platform service running as Docker? Well, let me take you through that. So the first thing, and the next thing we're actually going to do, is write a Docker file. And that's really just a set of instructions that tells Docker how to take our application, in this case our platform service, and turn it into an image. And again, remember, an image is one of those things that you can distribute somewhere into anything that's running Docker and allow you to run it as a container. So we get a Docker file, along with an application, we run it through the Docker engine, and we end up with an image. Okay, so we're going to do that next. We're going to write a Docker file, we're going to build and create an image, and then we're going to run up our image as a container, and then finally we're going to push our image up to Docker Hub, because we're going to be making use of Docker Hub a bit later on, but we're going to do all that next. All right, so let's get going and start with our Docker file. So just come over back into our project. Now, if you have anything running in your terminal, just make sure you shut it down before we get going. So in the root of our project, just right click, new file, and we'll call it Docker file. No need for an extension, and you can see by the wee blue whale that VS Code recognizes what it is. So I'm just going to get going and start building up our file. It's actually quite simple, and if you come over to Google and you just type in something like .NET Docker, this first article here, I'm basically just following this, Dockerizing the ASP.NET Core application in Docker, and there's a Docker file down here, which by and large, we're really just going to be following that, to be honest with you. Making some slight changes, but basically that's it. So the first thing we're going to specify is the image that we want to pull down from Docker Hub that we'll use to start our build. So the image is mcr.microsoft.com/.net/SDK. So we want the SDK image, which is a kind of larger image than just the runtime image, which we will also be making use of. And I'll just sort of specify the build environment name as build environment. And I'm just going to copy this, and I'm just going to push it into Google, and you can see where on Docker Hub that is hosted. So we just go to Google and paste in the image name. I think that should be sufficient. You'll see on Docker Hub that we have the .NET 5 SDK image, and with over 1 billion downloads, so it's been used by quite a few people. Now, if I just come back over to the main landing page for Docker Hub for my area on Docker Hub, you'll see I've got a few images myself that I've pushed up and hosted on Docker Hub. Now, we're going to be pushing up our platform service here, we're going to be pushing up our commands service here as well. It's part of the whole workflow that we're going to be following. So if you haven't done so already, please sign up for a Docker Hub account. I won't tell you how to do that, it's fairly straightforward, but you will definitely need to do that if you want to continue to follow along. But for now, let's get back to our Docker file. And I'm just going to set my working directory. So workdir/app. And then what we're going to do is we're going to copy over the csproj file so that we know what dependencies we actually need to work with in order to build our image. So copy everything from csproj and copy it to our kind of working directory. Okay. And then we want to copy everything else and build it. We copy from source, copy it to our destination, and then we just want to run .NET, publish, C, release. Got that wrong. There we go. Out. And then we want to build our runtime image. So what we're doing here is we are pulling down the .NET SDK image, which we're using to build the main part of our application, but then we want to actually make the image a bit smaller. And this is what I'm talking about when I've said multi-part build. We're now going to pull down the runtime image and finalize our build and just use that to package up our application. We don't need all the SDK stuff as part of our image. So very similar kind of syntax from mcr.microsoft.com against .NET, and this time the image is ASP.NET :5.0. Specify the working directory app, and then we want to copy the output from our build environment from equals build env to app out, and don't forget the trailing period. Get rid of that. Get rid of that. And then we set the entry point, and this is when our image is run. What actually kicks off, or what do we want to run basically? And so this is where we specify that. So entry point, say .NET, which is what we want to run, and then we actually specify the name of the DLL that we want. In this case, it's platform service.dll, and that should be it. Let me just double check this over. I think that looks right. So again, just to reiterate, this is the first image we're pulling down, the SDK image. We're creating a working directory. We're copying over the CS proj file. Oh, I've forgotten a line in here. We want to run .NET restore to basically pull down the packages contained in here that we need to build our image. So this is really important. So yes, copy those over, run .NET restore. I don't know why I missed that. We then copy those files over, we then run .NET publish. We then want to build our full runtime version without all the SDK gubbins. So we pull down the runtime image, create a working directory, and then we copy the contents of what we built over to that. And then we set the entry point for our image. So when we run our image, that's what gets kicked off. So if you actually come over to the bin directory, you'll see that we have a platform service DLL in there. It's just this thing here, okay, that gets run. All right, so that should be it for our Docker file. Again, if you want more information on this, I've kind of skipped through it quite quickly. Watch one of my other videos. We don't really need to revisit this now, that's it. And we're going to be doing a very similar one for the platform service, but it's literally going to look identical aside from the name of the DLL that we're going to run. So I'll probably just copy and paste it when we come to that point. But that's all we're really going to do with our Docker file. So next we're going to build our image, and you'll see how that works. We're going to run our image. We're then going to stop the running container, and we're going to push something up to Docker Hub. So we'll do all that in the next sections that follow. All right, so we're going to build our image. Now, before we build our image, it's very important that you actually have Docker running. So what I might do is just bring up a command line over here, clear the screen, and if you just type not .NET, I'm going to do that quite frequently, docker -- version, you should see that you have some version of Docker running. Now, I'm running Docker desktop, so the app is over here. So if you just bring this over onto the screen, let me just make that a bit more manageable so you can see it. Oh my goodness. There we go, that's a bit better. So you can see down here, this is Docker desktop on Windows. You can see Docker is running down in the bottom left-hand corner. Docker's running, and also Kubernetes is running. So if you go into settings, the cog up here, you'll see a number of options, one for Docker Engine, all that kind of stuff. But Kubernetes, make sure you have that ticked. And that will actually make sure that Kubernetes is running by default from memory. It's a long time since I've done it, since I've downloaded Docker Desktop. Kubernetes is not enabled by default, so make sure you enable that and that you see the little whale and the little ship's steering wheel for Kubernetes. So yeah, that's all running. All right, fantastic. So make sure you get that same response whenever you type in Docker at a command line. And yeah, we'll cover Kubernetes a little bit later, but we're just focusing on Docker for now. So what we want to do now is build our platform image. And as I said at the start of the video, I do have a cheat sheet that accompanies this video. You can go to my blog and register there to get a copy of the cheat sheet. So all these commands are in that cheat sheet. So building an image. So making sure that Docker is running, it is. So building an image, it's Docker build. And then we want to tag the build, tag the image with a name basically. And the name that you give it is the name, your username, your Docker Hub username. So mine is binary thistle, and then the name of your service. And I'm going to call it platform service. And from memory, if you put capitalization in here, it won't like it. So make sure everything is lowercase, so platform service. And then the most important thing, now you can specify a version if you want. We're not going to do that. We're just going to not specify a version. And if you don't, then it just tags it as latest, okay? Which is what we want. Most important thing that you'll probably always forget is make sure you put the build context, which is just the dot at the end of that command, okay? You'll probably always forget to do that. I do many, many times. So again, Docker build, and we're going to tag the image with a name, and in this case we want to give it the name platform service, but the syntax you use is the Docker Hub username. And the reason for that is when we push it up to Docker Hub needs to know which account it pushes that image into. So your name here is not going to be binary thistle, that's my name. You're going to have to put your name in, all right? So that all looks good. We just hit run. You'll see what happens. Basically, Docker just runs through the Docker file and it starts executing all the steps, as you can kind of see here. Now, I think I probably have those images locally on my machine, the Microsoft SDK images on my machine. If I didn't, then it would actually go to Docker Hub and pull down a copy of that. So it might take a bit longer in your case. If you've not done this before, it might take a bit longer to run. It's probably going to be relatively quick for me because I have those images. Now, one thing it will check to see that it's got the latest version of those images. So even in my case, it might download a new copy of the SDK image if the one I have is out of date. But that all looked pretty good. It looked like it built that all right. Now, one thing I will draw your attention to that I use all the time is this Docker plugin for VS Code. So you can go to your extensions and just type in Docker, and it's probably going to be the first one that comes up. I think it's this one here. Yeah, I've got it installed. You can see, you know, it's pretty well used, get high ratings. I really recommend it. So if you're using VS Code, strongly recommend you install that because you can kind of look at your images and stuff like that. So if we come over here and look at our images, and I'll just maybe refresh those, you can see here, there we go. I have this platform service image, binary thistle platform service image with the version latest. Okay, so that's all looking good. So that's building an image, pretty straightforward. So what we're going to do next is run this image up and see what we get. All right, so we've built an image. We have that available, as you can see here again, and we want to run our image as a container. All right, so let me just clear down our Docker file, and I'll come in here and just clear the screen as well. All right, so to run up our image as a container, the command you're after is docker run, and then you don't need to supply this next bit, but I'm going to supply it because if you don't supply this next bit, there's no way of us accessing the server running inside the container. If you run up a container without this, what's called a port mapping, you can't get into it. So what we're doing now is specifying an external port, a port that we're going to use in our Insomnia session to get into our container. It can be anything, as long as it's not running on your machine, and then the internal port that we're going into. Now, there's an awful lot of this port mapping type stuff that we're going to do, not just in Docker, but more especially in Kubernetes. So there's quite a lot of sort of networking-y stuff in here, which might surprise you, but probably shouldn't when you think about the nature of a distributed application. Anyway, digress for the moment. So we're running up our image as a container. So docker run -p for the port mapping, 8080, I'm using that in my case, to 80, which you will need to use. And then we're going to run it in what's called a detached mode. Now, if you don't have to specify this D flag. If you don't, then basically the container output will be displayed in this command line and in this terminal, and you won't be able to use this terminal to type at I want to retrieve it back and run a few more commands, but it's quite useful sometimes not to run it with the detached flag, and you can actually see some messaging flying through, such as errors or what startup stuff you're getting. But we're going to run it as detached. And then simply, it's just the name of your image. And this can be any valid image name. Obviously, in our case, it's platform service. And in your case, yes, it won't be binary thistle, it'll be whatever your Docker ID is. And in my case, it's obviously binary thistle platform service. And that's it. So again, if you are maybe wanting to pull down a SQL Server image, you could specify the SQL Server image here and run it up and do all sorts of stuff. You'd probably need a slightly different port mapping, but nonetheless, it's the same idea. Docker just goes to Docker Hub and pulls down that image. As we have this locally, Docker Hub in this case will not do that. Hit enter. And what you can see up here straight away, if you're using this plugin, you can see that we now have a container that is running, as denoted by this little green play sign, and we get a kind of ID of the container. So a couple other useful commands for you. Docker ps will show you the running containers, and basically we already have one running here, but if you're not using this, you can use the Docker ps command to see what running containers you have, and you'll have this container ID, which is this thing here, which we can reference, copy that, and issue a Docker stop. Give it the container name, container ID, and you'll see that up here, yes, it's been stopped, and if we do a Docker ps again, we have no running containers. Okay, so that's stopping and starting a container. Now, if we do Docker run one more time, what do you think is going to happen? Do you think this is going to run up? Well, let's give it a go. No, that doesn't happen. What happens basically is you're telling Docker to run this image. So it's going to this image again, and it's running up another container. It's not restarting the same container that you had last time. So just be aware of that. Every time you run Docker run, it's basically running up a container. Okay, and again, Docker ps, to get our running containers, it's got a different ID this time. Let's copy that, and let's do a Docker stop. Paste that in, and you'll see that too has stopped. So what if we just want to restart the same container? Well, that is then Docker start. Okay, and then we actually give it the name of the container or the ID of the container that we want to restart. So if we do that, you'll see that the same container restarted. We didn't get another one. Okay, so Docker run to go to an image, run it up. If you keep running that command, it will run up new containers every time. Docker stop to stop it. Docker ps to get a list of running containers, and then Docker start with the container ID to restart an existing container. And that's, other than one other command, which we'll cover in a bit, that is the only, they are the only commands that you really need to work with. Or you can just use this interface here. So you can right click here, for example, and stop it if you want to do that. Okay, so I did mention there is one other command, and it's one command that we're going to be using an awful lot. More than Docker run and Docker stop, we're going to be using this command, Docker push, along with Docker build a hell of a lot, a heck of a lot throughout the rest of this course. So let's go and do a Docker push, and then we're just about ready to move on to Kubernetes. All right, Docker push. Now, to be honest with you, the command is incredibly simple. There's not really much to it. But what I'm going to do is I'm just going to bring over my Docker Hub page again. Let's come over here. So this is logged into Docker Hub as binary thistle, and you can see I have a few images up here already for other projects, but there is nothing in here that says platform service. That does not exist here at the moment. Okay, so we'll pull that back over, and back over in our command line. And let me actually just clear the screen, and we're going to Docker. Any guesses what the command's going to be? That's right, Docker push, and then it's just the name of our image, binary thistle, and again in your case it's going to be your Docker ID platform service. Platform service, cool. And you can see one of the things it's saying it's using the default tag latest, which is exactly what we want, and then it's just going to start pushing this container up to Docker Hub. So it depends how fast your upload speeds are on your internet connection. Mine used to be really, really fast, but for some reason it's got really kind of quite bad now, so it takes quite a while. So I'll probably cut the video because I'm sure you don't want to watch me uploading an image, but that's it. It just uploads the image. Now, Docker's quite clever in that images are built up in what are called layers, okay? And so this is going to take a while because we've not uploaded it before, but if I upload it again and I've only made some minor changes, you'll usually see that the upload will be a lot quicker because it's not going to upload everything again. It's only going to upload what's called the affected layer. So it's a lot more efficient. But as this is the first time we're doing it, it's going to take quite a while. So what I might do is I might chop the video here and I'll come back. Won't touch anything else. I'll come back once it's uploaded. But basically, that's pretty much it. But we'll wait for it to be uploaded. We'll check Docker Hub and then we'll move on to Kubernetes. Fantastic, so that looks like that's pushed up now. If we come back over to Docker Hub and if I refresh the page, we should see Binary Thistle Platform Service up there, and we just click on it. Yeah, you can see that we have the latest build up there. We've not really versioned it. Cool, so that's push complete. We're going to be using that an awful lot as we move throughout the rest of the video. But next, there was one thing I actually forgot to do, which was actually when we ran our container, take a look at the container running to make sure that we can get to it using that port mapping. So we'll do that next, just before we move on to Kubernetes, just to show you that that's all working. So we'll do that, yeah, do that now. All right, so back over here, let's just let's start one of our containers that we already had. Fantastic, and if you do a Docker PS, see you're running, not PSA, PS. Yeah, you can see it's running and you can see we have this port mapping. So let's come over to Insomnia again. And we've got that here. So we can see we've got our local development environment, a platform service. I am going to create another folder, top level folder. I'm going to call it, although it's technically our local environment, I'm going to call it our Docker environment. And I'm going to create another folder in here. We're probably not going to make too much use of this, but we'll keep it segregated because we might flip back and forward between them, platform service. And then I'm going to create a new request. I'm just going to call it get all platforms. Just a get request, create that. Now what I might do is come over here. I'm just going to duplicate that. Yep, and I'm just going to, no, actually, so we can just delete that then. Delete. Click to confirm and just move that into here. Now obviously, if we click on this, it's using localhost 5000. We don't want that, we want to use 8080. All right, and let's see what we get. There we go. So that's how we are getting to our Dockerized image rather than directly on, directly when we were running it is .NET Run. Okay, so these are the two differences between the two. And actually, as we move through the video, we're going to have other ways of, because eventually this container is going to be running in Kubernetes, so we're not going to access it in this way either. We're going to access it in two different ways, actually. So it all gets, not complex, but yes, it's quite complex. It can get quite confusing. So that's why I'm being really careful to segregate which environments I'm running where, because it can get a little bit convoluted, let's say that. But yeah, anyway, that's it. The container's running. We can get to it in that way. Now, just before we move on then, what I will do is I'll just stop this container with a Docker stop. I think that's the same one, isn't it? There we go. Stop. All right, great. So that's a bit of a review of Docker, a bit of a crash course on Docker. I think that's enough to get us going. Docker file and some core commands, we're good to go. We'll be using Docker build a lot, and we'll be using Docker push a lot. But now it's time to move on and take a look at what Kubernetes is. All right, so let's move on to talking about Kubernetes. Now, the reason I've got an onion on screen there is not because Kubernetes makes you cry, although it can get quite frustrating from time to time. It's because, well, the way I think about it is very much like the layers of an onion. There's lots of layers involved in Kubernetes. And when I was first learning it, that's kind of how I envisaged it. So, massive subject area, but what is it in a nutshell? Basically, as you saw in the last section, we were running up multiple containers using Docker Desktop to do that. That's obviously fine for development purposes, but when you're moving into a microservices architecture and you're wanting to kind of make sure your containers continue to run, and if they crash that they get restarted, or that you want to scale them out, clearly you're not going to be running around at a command line doing that. So that's where something like Kubernetes comes in. Kubernetes is a container orchestrator. And you know, it's a good name, and the analogy I think fits really well. The Kubernetes is like the conductor of an orchestra, and it makes sure everything is running as it should, running to time, if you want to put it like that. And again, yes, responsible for making sure things run in the right way, scale out in the right way, all that kind of stuff. And we're going to be working a lot with Kubernetes in this section and the sections going forward, and we're going to tell it how we want it to run things, I guess. So we're going to give it like an end state, an end state that we want it to get to, and Kubernetes will figure out a way of doing that for us. It's pretty cool, actually. Huge subject area. And actually, one of the things I was thinking about when I was making this video was, do we use Kubernetes? Because it can be quite tough. It can be quite a difficult subject area. And I did think about using something like Docker Compose. Docker Compose is, I kind of like to think of it as a middle ground between Docker and Kubernetes. Docker Compose kind of almost sits in the middle. It allows you to run up multiple containers and network them together. And it's actually a very nice option in, development type environments. But production-wise, Kubernetes is really the option that you would be going for. If you're interested in if you're interested in Docker Compose, I've done a couple of videos on Docker Compose to see how that all works. But Kubernetes, it's the main event, and that's what we're going to be using in today's video. So just a little bit more about Kubernetes. I think really the best way of understanding it is to actually start working with it, but I'll give you a bit of background, and then we'll go through the architecture of the application we're going to build in Kubernetes next, and that will introduce you to some of the terms and concepts. But again, actually working with this stuff is definitely the best way to learn about it. So it was built originally by Google. It's now in the public domain, or it's now open source, and it's maintained by the Cloud Native Foundation. Often referred to as K8s, simply because there's 8 letters in between the leading K and the trailing S. And I may write Kubernetes as K8s. I'll probably still say Kubernetes though. It's a container orchestrator. Huge subject area. So again, in this video, we're going to learn enough to be dangerous. We're going to learn enough as developers to get started and run stuff in Kubernetes, and it will be a fully fledged microservices type deployment, but it is a massive area and we're really only scratching the surface of it. I like to think that there's 2 broad user profiles. Some people may disagree with this assessment, but I think of developers using Kubernetes. So for the most part, that's the audience I'm focused on in this video. As developers, we want to run stuff on Kubernetes, okay? And what sits beneath it and how it's set up, personally, I don't really care too much about that. That's for really, I think, the second kind of category of user, and that's like the DevOps engineer or the administrator or whatever you want to call them, because there is a lot of setup required, and it's people's entire roles just to run Kubernetes and keep it running, okay? I'm not too focused on that, and I'm certainly not going to go into that in today's video, because number one, I'm not really that interested. Number two, I don't know that much about it, to be honest with you. I just use Kubernetes as a platform, and that's what I'm focused on today. All right, so let's go through the architecture a bit. Now, when I'm talking about Kubernetes architecture, I'm not talking about the internal architecture of how the Kubernetes system is composed. Again, don't really care, to be honest with you. We'll cover bits of it as we move, maybe little bits of it as we move through the video, but I really don't care how it runs underneath. It's not that interesting to me. I'm talking about how things run on top of it. That's really what I'm referring to as the architecture that we are going to build out throughout the rest of this video. That being said though, I have provided a very, very simplified view of how it kind of runs on top of my local machine in this instance, and how it would run theoretically on something more complex like a cloud environment, something like that, just to give you that context. All right, so let's get started there. So in our case, and I'm sure in your case as well, you're running this on a PC or a laptop or something like that. So I have my bare metal PC on that. I'm running Windows 10 Pro. And just out of interest, I'm also running the Windows subsystem for Linux, which is basically like Linux running on a Windows machine. And the reason I'm running that, a couple of reasons, but the main reason is actually when I run Docker, Docker actually uses the Windows subsystem for Linux to run containers effectively. It uses that part of the system to do that. It doesn't have to. If you're running Windows 10 Pro, you can use the Windows containerization platform. Can't remember what it's called, but you can use that. That's not available in Windows 10 Home. You have to go down the WSL2 route, but I've gone down that anyway because I think it's actually a nicer option, to be honest with you. So again, got your hardware, in our case it's just a PC, you got your operating system, in my case Windows 10, and then you've got your container runtime, in our case Docker. And then, not strictly correct, but I'm just saying Kubernetes then runs on top of that. So Kubernetes is this platform on which we can build stuff. And again, I'm not going to delve into how Kubernetes is architected internally, not too bothered about that. We'll touch on some concepts, as I said. Now this is really where we come on to talking about the architecture of the application that we are going to build. Now one point I'll make here is there's a lot of information on this screen, and I do not expect any of you, if this is the first time you've used Kubernetes, to memorize this now and need to memorize it going into the next section. That's not the reason I'm giving you this information now. The reason I'm giving it to you now is, number one, to start to familiarize you with some of the concepts, not asking you to memorize it. Number two, to give you an end state, because one of the things I found quite overwhelming when I was learning Kubernetes for the first time was all these concepts just kept getting thrown at me, and just when I thought I'd got a handle on it, more stuff kept getting thrown at me, and I was like, oh my god, there's never an end to this. And so the reason I'm giving you the end state architecture is so that you have that end view, that you know that we're working towards an end goal, and we can kind of tick off our progress as we move throughout the video. And so we will keep referring to this architecture as we build it up throughout the video, so we can see what progress we're making. And in that way, I think you'll kind of understand, number one, the concepts, and number two, that you are making progress and that there is an end in sight. So the first kind of high level object, let's call it that, is this term cluster. So this is a Kubernetes terminology now, and this is kind of what we're going to start focusing on. Docker Desktop is a single cluster system, okay? And multi-cluster systems obviously do exist, but they are kind of quite heavy going. They are like full-on enterprise type setups. We're definitely not going to touch that. I'm definitely not going to touch that. But from our purposes, we're running on a single cluster, and that is Docker Desktop. A little bit more digestible then is this term a node. And again, Docker Desktop, single cluster, single node. And those two terms, I might even do it myself, they kind of almost get used synonymously, not technically correct. Cluster, node. And so within one cluster, you can have multiple nodes running. And for example, if you, I did think about developing this video on something like Google Cloud or Azure, you're probably going to be running on a single cluster, but certainly in the case of Google Cloud, you would be running in a kind of multi-node environment. But again, not really that relevant to the video today. So Docker Desktop, single cluster, single node, okay? But you can have multi-nodes, obviously. Now we're going to start to delve into really what we are building out. We don't have to set up a node, we don't have to set up a cluster, it's just there, okay? That is already there. The fact that we have Kubernetes running, we have a cluster, we have a node. We don't have to do anything with these. And so, to be honest with you going forward, not really going to refer to them too much after this, so you can kind of almost, not ignore it, but just kind of put it to the back for the moment, okay? But with inside our node, this is really what we are going to be standing up and running. So the first concept really that you're going to have to get your head around, and it's not that complex to be honest with you, is this idea of a pod. Now what is a pod? A pod runs containers. So as in the last section when we're running up containers at the command line, a pod is used to host and run containers. Now a pod, a single pod, can run multiple containers. In this video, we're not doing that. It's one pod, one container, okay? Now a container and a pod are different things, but for the purposes of this video, you could almost use those terms interchangeably. Not technically correct, but I'll forgive you if you do that, and I might do it myself. So pod container, one-to-one mapping in this case. However, in the real world, you can have multiple containers running in a pod, but we're not doing that today. All right, so the first thing we're going to do is actually take our platform service image and run it in Kubernetes in a pod. First thing we're going to do, and we're going to do that using something called a deployment, but that's for later, okay? So pod is the first level object that we are going to start working with. Now, in the same way as with Docker, we can't actually access that running container now. It's not accessible from within Kubernetes. So what we're going to do next is set up something called a node port. And a node port is what's termed a Kubernetes service. And there's a number of services we're going to work with throughout the rest of the video. Node port is the first one. Node ports are really used only for development purposes. You wouldn't use a node port in a production type environment. So it's really just to allow us to test and get access to our pods, okay, and our containers as well. So it will give us Kubernetes will give us an external port that we will use. It will more than likely begin with it. In fact, it will begin with a 3, and it's usually a 5-digit port number, semi-randomly assigned. Think of it almost like the port 8080 that we used in the Docker example. We'll also have the port mapping, the internal port mapping, in this case, port 80. So external traffic will come in, and it will hit directly our port 80 of our running container in our pod. And it means we can test to make sure that it's all up and running. It's running okay in Kubernetes and we can access it. So that's the first thing we're going to do. Next thing we're going to do is set up another pod with our command service running in it. Now, obviously, we're going to have to write our command service. That doesn't exist yet, but we're going to write that, build it as an image, push it up to Docker Hub, and put it into a pod running in Kubernetes. In order for these two pods to talk to each other, they need to get what's called a cluster IP service. And you can see on here, you have your pod, and then you'll have a cluster IP service for each of the pods that need to communicate to each other. And again, there's this kind of concept of a port mapping. And that will allow our platform service to talk to our command service and vice versa. Next thing we're going to do, the node port, as I said, is really only used in a development context. In production, you would not use a node port. So what we're going to do next is set up yet another pod with something called an ingress Nginx controller. As it says, an ingress Nginx container, but it's really an ingress Nginx controller running as a container. And what that basically is, it's almost like an API type gateway. So I have done a video previously on Envoy as an API gateway. Nginx is on a competing kind of platform that does a similar thing, and we're going to use that in this case to basically act as a gateway for our two services. It's going to run in its own pod. It's going to work in conjunction with something called an ingress Nginx load balancer, okay, and that's another service. And so external traffic will come in via the load balancer. It will talk to our ingress Nginx controller, and the ingress Nginx controller will route directly to our two services. Okay, it won't actually make use of the cluster IP services. They are really just used generally for container to container communication. The ingress Nginx control in this case is going to reach out directly to our services. Next thing we're going to do is set up a database, a SQL Server database, because at the moment we're running internal in-memory databases for both our services. So we're going to stand up a separate SQL Server just for use by our platform service. And it's going to have a cluster IP as well, so it can talk to the other services. The other thing it's going to have is access to persistent storage space, because our platform and command services, they can reboot, they don't need to store data, they're stateless. That's fine. SQL Server, it's a database, obviously it can't be stateless, it needs to store data somewhere. So we're going to use something called persistent volume claim to claim some storage on our physical disk. Now that area is starting to go into the domain of the DevOps type guys, the administrator type guys. It's not strictly a developer area. Persistent volume claims, that's fine, that's a developer realm, but when you start going further down the food chain and you start talking about persistent volumes and storage classes and then setting up storage, that's starting to go into the realms of the DevOps type guys. Fortunately for us, we can just set up a persistent volume claim and that will do what we need it to do. And it kind of reaches down onto a physical disk. The final pod we're going to set up is our RabbitMQ message bus. And again, cluster IP, and it will allow us to talk to all the pods to talk together within our node. Now, one thing you'll notice here, you'll probably go, where is the SQL Server for our command service? In this video, just for the purposes of saving some time, the command service is going to have its own database, but we're just going to keep it as the in-memory database. Still has its own database, can't stress that enough. It's not using the same database as the platform service, using its own database. We're just going to keep it in memory. And maybe as a bit of homework, once you start to get familiar, you can spin up a second SQL Server just for it. But again, main takeaway, it's not got a SQL Server, but it still has its own data store. Very, very important. And then these cluster IPs, maybe not the best diagram. Basically, it's not saying that the platform SQL Server just talks to the RabbitMQ database, blah, blah, blah. It basically means all these four things can talk together. Okay, they're all chained together, they all talk together. Maybe not the best diagram. But yes, this is our end state. This is what we're going to set up. This is what we're going to build. And as we move through the rest of the video, we're going to refer back to this time and time again to make sure that we are making progress. So with that, I think enough theory. We're now going to move on to creating our first pod in the next section. All right, so back over on our application, just make sure you don't have anything running. And what we're actually going to do is we're going to move out of just working within the platform service project, and we're going to basically work within a kind of more, I suppose you'd call it a solution type context rather than just a project context. So in your command line, if you just come out of the platform service, and so we'll do a directory listing and you'll see that we have the platform service there. And I'm just going to come up one more level and do a listing. Now, all my solution is going to be within this E3 folder here. So what I'm going to do is type code R E3. And that's going to reopen Visual Studio Code. And we've still got a platform service here. You can see everything in here, but we're now going to create another kind of project level folder. I'll just say yes to that. All right, and that's going to contain our Kubernetes assets, mainly our deployment files. So when you're working with Kubernetes, there's a number of ways you can set things up. You can run things at the command line to deploy pods and do all that kind of stuff, or you can write files, deployment files. And that's the approach we're going to take because it's much more reusable than doing stuff at the command line. So in our in our solution context now, we're going to create a new folder, and I'm just going to call it K8. Now, as I said in the previous section, K8 is really just related to the Kubernetes stuff that we're going to be writing. So it's not a .NET project or anything like that. It's just going to be a bunch of deployment files. So the first thing, as per our diagram, and if we maybe just pay it a little visit again, if we come back over here, I'll just bring it back up on screen. I'll need to get a more static version of this. Yeah, the first thing we're going to do, actually, yeah, that's actually working okay, is deploy a pod with our platform service in it. That's what we're going to do next, and then we'll come on and do the node port. But for now, that's what we're going to do. So within our K8s folder, right click, new file, and we're going to create a deployment file for our platform service. So we're going to call this platforms-depl.yaml. Okay, so it's a YAML file, as the name would suggest, and depl obviously is just short for deployment. All right, so I think probably the best way to approach this is just to start typing it out and trying as best I can to explain it as I go through. It's a bit long-winded, and there seems to be, you'll probably think there's a bit of repetition in this file, but everything is necessary, unfortunately, and YAML files, yes, are white space sensitive, so just be careful as you work through them. But if you follow along, should be okay. And remember, the code is on GitHub, so you can pull down this file if you do run into problems following along yourself. So the first thing we specify is an API version. So colon and it's apps /v1, and that's just specifying, yeah, the API version that this deployment file is going to use. Under the covers, Kubernetes actually works with basically a REST API essentially to create and destroy its own resources. So that's basically what we're specifying there. What kind is it? Well, it's going to be a deployment. So again, we're deploying something into Kubernetes, and as we work through the course, we'll have different kinds of these files. I don't want to populate it with all that stuff. Next thing is metadata, and we give it a name, and this is really just the name of our deployment. Okay, so we're going to call it platforms-depl for our deployment, basically. And then we come on to our specification, and this is really where we specify our pod effectively. So tab in, and the first thing we're going to specify is the number of replicas. Now, as I said when we were talking about Kubernetes, you can horizontally scale out the number of services that run. So we could have 3 instances of our platform service running if we wanted, and that's what's referred to as a replica. Here we're just going to have a single replica. We're just starting with one, at least to begin with. Now these next, there's going to be 2 bits that follow. Let me just type them out first, and then let me describe them, because they're a wee bit confusing, to be honest with you, but yeah, again, they're mandatory. So the first thing is a selector. And we come down and indent once again, and then we type in match labels, and it's actually getting some help with it. And then app, and we're going to call it platform service. Now we're going to back out again. We're going to stay within our spec, but we're going to be directly under our replicas and our selector tag now, and we're going to define a template. We're going to give it some metadata. Don't forget the colons, tab in. And again, you've got to be really careful with this white space here. And we're going to give it a label, or labels. And we're just going to give it a label of app, and again, platform service. We'll just select that from there, basically. Now, these two things, the selector and the template, kind of work in combination with each other. And really what we're doing within this template, it's within here that we're really defining the pod and the container that we're going to use. And then this selector is basically selecting the template that we're creating. Okay, so it's a wee bit kind of convoluted, but this template stuff is where we're defining what we're deploying, and then the selector is basically selecting it for us as part of the deployment. And then under there, we're going to back out to underneath metadata, so we're still within our template section, but directly under metadata now. And this is where we're going to define our spec. And under spec, tab in, and we're going to specify the containers that we want to run. And we're almost at the end, don't worry, we're almost getting there. And anything within YAML that has this kind of minus sign, that's an array. And you can even see by the name containers, it's plural. You could have multiple containers that we wanted to deploy. But in our case, we're just deploying one. We're going to give it a name of platform service. And what I want to do is just select this and make sure that we have these three things are called exactly the same thing. So the match label, the template app label, and the name of our container are all platform service. And then finally under here, just tab in under the name, we want to define the image. And this is just the Docker image for our service. So image colon, and then we just specify binary thistle / platforms service, and obviously make sure this name is the same name as the service that we have defined, or you have defined. And again, remember, this will be your Docker Hub login ID, and we do actually want to specify latest here. Okay. Now this complaining is just complaining about we're not putting a couple of other things to do with resourcing limits. I'm not going to bother doing that, so I'm going to ignore that kind of warning. Now that's it. That's basically a deployment for a container into a pod. Okay. So if you save that off, we'll find out if we have made any mistakes, but it looks okay for the moment. So again, probably for me, the most confusing thing is this selector thing, but really all it's doing is it's selecting this thing here that we've defined as part of our template. That's really all it's doing. Now we're going to come back in here a bit later, and we're going to define our cluster IP service in here as well. If you remember from the previous architecture diagram, we're not going to put it in yet. We're going to do this all step by step, one step at a time. That's cool. So remember to save off, and yeah, now having defined our deployment file, we're going to actually effectively run it and deploy it into our Kubernetes cluster. All right, so back in our application, we are going to bring up a command prompt. Fantastic. Now, before we do anything else regarding our platform's deployment, what I want to do is just make sure that Kubernetes is running appropriately. Now, I believe I did anyway, bring over Docker Desktop, and I said to check that you have Kubernetes enabled and that it's got the little running instance down here. And that's looking all good. But one of the other things that we rely on as part of Kubernetes, and this is sort of starting to go into the architecture of Kubernetes itself, is basically the command line that we are going to use to drive all of this stuff. And the command line is kubectl, okay? And so if you type kubectl version, this is the command line tool we're going to basically use to issue all our commands. You will see, hopefully, if it's running correctly, you'll see a client version and a server version and all that kind of stuff. Doesn't really matter what the versioning is, just so long as you get something back. That means Kubernetes is up and running and the kubectl command line is all good to go. So let's clear the screen. And again, All these commands, or most of these commands, are in the cheat sheet that I talked about at the start of the video. So let's just do a directory listing where we are. We're in the, oh goodness sake, we are in, oh my goodness. We can see that we've got a platform service, and we can see we've got a K8s folder. So we're going to change into our K8s folder and do a directory listing to make sure that you can see this platform's deployment file. And we're now going to apply that file. And so it's kubectl, apply, f, and then the name of the file. So this is platforms-depot.yaml. And if there's any issues with it, you'll get an error at this point in time, but that looks okay. So we've got a command that comes back saying deployment apps platform depot created. Okay, what does that mean? So if we do kubectl get deployments, because basically we've created a deployment. I'm going to spell kubectl wrong. There we go. You can see here that we have something called platforms depot, 0 containers ready, or 0 pods ready, and 1 is up to date. So let's keep an eye on it. But the other thing you can do is see your pods running. So kubectl get pods. Now you're probably starting to see a bit of a pattern emerging here. With this command, you can use kubectl get whatever. So you can get deployments, you can get pods, you can get services. You can see here that we got 1 pod within our cluster now, and it's ready and it's running. So that looks good. Let's just get deployments again, and you can see now that 0, from 0 being ready to 1 being ready, it's all up and running. That looks really good. Okay, so I think if we come over to our Docker plugin, you can actually see here that we have a running container running in Docker, but isn't it supposed to be running in Kubernetes? Well, yes, obviously it is. Kubernetes is orchestrating it, but it still has to run in Docker. Now what I'm going to do is I'm actually just going to delete these 2 containers that we had created in the previous section, because it's just going to get way too busy. All right. Now the other thing I want to do then is come over to our Docker desktop. And if you come over here, it's making itself rather big, and we just go into general. Actually, we cancel out this. And we come over into the kind of main window. Actually, to be honest with you though, I actually find the Docker desktop interface can be a wee bit confusing sometimes. So if you go into settings, this is where our settings are, and you cancel to come out of that. This is kind of showing you running stuff. Now, the first thing you'll see is, well, wait a minute, there's actually 2 things running here. How is that possible? Well, this is a pattern that you'll see sort of time and time again. This is actually the running container. And this thing here, as you can see from the name, is actually the pod that's kind of running. So you can click on that, the actual container one, and you can look inside and you can see basically output from our service running in Kubernetes. And it looks very familiar. It's seeding data because we've got using an in-memory database. And you can see here it's listening on port 80, which is basically what we saw when we ran it in Docker as well. All right, so that's all looking really good. So give yourself a round of applause. You've created your first deployment and you've deployed a service into Kubernetes, and it's running and waiting for us to start using it. Fantastic. So in the next section, what we're going to do, we're going to do a little bit more work here just to show you some of the things that Kubernetes can do and how it actually orchestrates services. And then we'll eventually come on to working with our node port. All right, so one of the things I want to show you, and it's one of the things that kind of confused me a little bit about the whole Kubernetes setup, was, okay, what happens, and maybe this is my destructive nature, what happens, here's our running container here, what happens if I delete this? Okay, so let's stop it, and let's delete it. Let's remove it. What happens then? Anything. So if we come back to our command line, and we do, let's do kubectl get pods, you can see that we've got our pod here, and it's saying 0 of 1 is ready. If we do it again, it's now saying 1 of 1 is ready, and you can see now that a container is running again. We come back over to Docker desktop. You can see that we have, the container has come back. We've stopped it, we've destroyed it, but it's just bounced back and come back up. How is that? Well, that is one of the whole points around the Kubernetes. It auto recovers your containers for you. So if a container crashes, for example, something bad happens to it, because we've told Kubernetes as part of our deployment, come back to our file over here, and look at our deployment file. Because we've told it we want a deployment, we want one replica, Kubernetes is going to do everything in its power to ensure that there is one replica of our service running. So even though we explicitly destroyed it there, it still came back and runs again. So you can change that behavior if you want, but the whole point of Kubernetes is that you've told it to do something, you've given it the end state, it will make sure at all times that that end state that you've specified is being adhered to. So that's one of the very, very cool things about it. Now, that's not to say that you cannot destroy things, because that's kind of what I thought originally. You can. So again, if we come back to our command line, you can do something like kubectl. Actually, let's get our pods, get our deployments first. So kubectl, get deployments. And we have a list of deployments, and then we can go kubectl delete deployment, and we'll take its name, and we will delete the deployment. Okay, do a upkey, get deployments. There are no resources found. And if we come back over to our Docker desktop Kubernetes instance, you can see basically it has destroyed everything. We've destroyed the deployment, we've told it to delete the deployment, and there you go, it's taken everything down. All right, so just one other thing, just to show you how easy it is to tell Kubernetes to run 3 instances of our service. We can just change the number of replicas to 3, save that off. Upkey, and we'll go back to our apply command. So kubectl apply f platforms depl YAML, and we will hit enter. And clear the screen a wee bit here, and if we do kubectl get pods, you'll see that there are 3 pods. They're not started yet, but Kubernetes now is attempting to start 3 containers for us. And if we keep refreshing this, it will eventually, unless there's an error in our image, it will eventually reflect the fact that we have 3 running containers as part of our cluster. Okay, so you saw how easy that was. So again, the idea is if you're seeing high traffic on one particular service, you can quite easily spawn up 2, 3, 4, however many services, and you can deal with that increased demand. Of course, there are design considerations with the way you've built your service. That there may be other things you have to consider, but in our case, it would literally be that easy. So you can see here, we've got 2 containers up and running, and this other one is in this container creating state. So it's still spinning up, and I'm sure eventually you will see all 3 will have started. So unfortunately for those 3 containers, there they are, they're all up and running, and we come back over to our Docker desktop view. You can see that we have our 3 services running, and then we have 3 associated pods, 1 for each platform. And that's a pattern that you're going to see time and time again. You're going to see these pods paired with a service. All right, so no sooner had we spun that up, I'm going to delete it because I don't want three services running. So we'll upkey, and we'll delete deployments platforms depl, and then we'll do get deployments, kubectl get deployments. And we have no resources found, which is correct. And we'll just double check. Yes, it's in the process of deleting. That's cool. So I'm going to come back here before we move on, change that back to 1, save it off, and then for one last, not for the last time, but the last time in this section, we're going to reapply our deployment and get our 1 service up and running. So that's all good. We have a service up and running, but we have no way of accessing it yet. So we're now going to create a node port that will actually give us access to see if we can query this service running in Kubernetes. So we'll do that next. All right, so we want to create a node port now, and a node port is one of a few different types of service that we can create. But just before we do that, just run a kubectl get pods, just to make sure that the pod that we kind of recreated, or the deployment that we reran in the last section with our 1 pod is now up and running. So we have 1 pod running, that's cool. So just make sure you do that before you go any further. So yeah, we want to create a node port now. So if we maybe just come back to our diagram, it's probably worth just taking a quick look. So we've done this now, well done. We're now going to create a node port, and that's going to allow us external access into our service. Now, you'll see on here, we are going to create a node port. We're going to specify this port here, which is just referred to as, well, you'll see in a minute in the file, the port, and this one here, this 80 is the target port. We don't specify this 30,000 port. Kubernetes does that for us. So we specify 2 ports, this one here and this one here. All right. So back over in our K8s folder, if you right click and do new file, I'm going to call this platforms np-srv just to keep it kind of short. So .yaml, don't forget the YAML. So platforms node port dash service .yaml. All right, so I might just pull this down a little bit. And over in our folder, in our file, sorry, we're going to specify an API version again. This time it's just v1 as we're dealing with services. The kind this time is going to be a service. Whoop. I don't really want it to auto-complete it for us, so a service. Again, our deployment was a deployment type. This type is a service type. And we're going to specify some metadata. And this is really just the name that this service will be known as when we kind of work with it at the command line. So I'm just going to call it platform np service -srv. Okay, platform np service srv. Yeah, okay. Some of these names can get a bit unwieldy, so you have to be really careful that you type them in correctly. And then we specify a spec section, tab in, and the type, in this case, is node port. And then we're going to work with our selector. I'm going to specify the app. Now this is where we pop back over to our platform's deployment file and we pick this value here, platform service, okay? So it's basically, it's another selector and this is what we are. We're selecting the same thing. Okay, this node port is going to be working with this platform service. It needs to know where to reach out to. And then we come back and then we specify the ports. So we're going to specify a name. From memory, the name thing is not mandatory, but I'm going to put it in anyway. I'm going to give it the same name as this. I think you need it if you're specifying more than one array of port types. And you can see here, this is an array that we're defining, or array element, should I say, that we're defining. So protocol is just TCP. Port is 80, and again, that's the port on the node port. And then target port is the target, it's the port of the service that we want to talk to. And that should be it. And again, yeah, if we were defining another, set of ports, then you actually do need the name in that case. If you're just defining one, I don't think you need the name, but we'll leave it in anyway. It makes for more descriptive reading anyway. Cool, so we'll save that off. Now, in a very similar way that we did with our deployment, all we need to do is do kubectl, apply, f, and then the name of our file. Now actually, maybe before we do that, we'll just do well, I can see we're in the folder, but just do a directory listing to make sure that you're there. And yeah, let's go for it. kubectl, apply -f, and then it's just the name of the file that you want to apply. Great, and again, we can see we've got a service created. If you don't see this, you will obviously see an error. Again, the errors, I think I've said this before, maybe I've not. If I haven't, the errors are quite good. They're quite descriptive. They usually get you to the root of the problem if you have made a mistake. So, although it said created, how do we know for sure that it's created? Well, you use kubectl again, get services, and you can see that we have 2 services here. Now this one here was actually here by default. It's there already, so we can kind of leave that one for the moment. Don't need to worry too much about that. But this is the one that we have just created. So here's the name, as we specified up here in the metadata, and then you can see that it's a node port, and you can see port 80 is the internal port, and this is the port that we need to use to actually access the service externally. So let's move over to Insomnia again, and I'm going to create another top-level folder, this time for our Kubernetes environment. So a new folder, and I'm just going to call it K8s. Okay, So we've got one for local development, one for Docker, and one for K8s now. And then we're going to create another folder here for platforms, platform. Let's just keep it consistent. Platform service, let's rename that. Rename. Probably being a little bit pedantic, but want to keep it consistent, otherwise it can get a bit confusing. So platform service, and then we're just going to duplicate this one here. Okay, and we'll move it under here. But unlike, we don't want to use 8080, we want to use that other port that Kubernetes has given us or generated for us, so it's here. So if we just copy that, try that again, so it's 30, 40, 70. We come over here and put that in here. And yeah, it looks right. We query, there we go. We have access to our service running in Kubernetes, which I think is very, very cool. So give yourself a round of applause for that. We're making very, very good progress. So basically that is, well, that's not it. Obviously, we still have a long way to go, but let's refer back to our diagram to kind of check on progress. So we've now done this, that's fantastic. So really the next thing we want to do in the next section, we're going to concentrate, we're going to go back into writing .NET C# code, and we're going to construct up our command service, and then we're going to do a very similar thing and deploy it in here, and then we're going to get them talking to each other, and then it starts to become much more interesting, because then we're really going into microservices concepts. We talk about how these services can talk to each other synchronously or synchronously or both. So yes, next section we're going to move on to is to construct our command service. All right, so now what we're going to come on to do is create our command service in our kind of solution area. So back over in our, it's not really our project anymore, back over in our solution, just make sure you stop any running services. And let's close this stuff down as well. All right, so make sure that you are in the kind of top level of the solution. In fact, we're going to need a command line. So in the command line, just do a directory listing to make sure that you're in the top level solution area. You can see the platform service in K8's folders. And we're going to scaffold up a new service or commands service. So .NET new, so web API, and the name is command service. Hit enter, and that should go away and scaffold up our command service. Fantastic, and it appears here in our directory listing. So next thing we want to do, I'm just going to get rid of this, is bring up your CS_proj file so you can see what package dependencies or package references we have in here, and we're going to add some more in a very similar way as we did with our other service or platform service. So .NET add package, and the first one, again, I'm going to just copy the first one. In fact, I'll probably copy most of them over. Save you watch me typing, is automapper. We're of course going to use automapper here as well, so I think I must have done something wrong. Oh yes. So what I haven't done is change in to the project that we want to be working with. So cd into command service. There we go. So what it was complaining about there was I was trying to add a package reference, and it's complaining that there was no project file basically. So there we go, rookie mistake, and there we go. So we've got automapper added into our CS_proj file now. Fantastic. So we're going to add a few package references here. I'm not going to add all the packages that we need. I'll add the ones that we're going to need in the kind of near future. The ones that we'll work with a bit later down the line, I'll pull them in a bit later. So the next one is add package Microsoft Entity Framework Core. And just make sure it's added into the CS_proj file. I'll do up key, and then we need exactly the same, but this time design. And again, this is mostly the same. In fact, it's exactly the same as the platform service as well. Now, I did debate whether to just, skip this, not skip the section, but, not go through all the setup again, but I think it's good practice for you to go through the setup again anyway, and it kind of embeds what we need to do, and it is only one other service, so I think it's probably the right approach. And then we're going to add in memory. Now, as I said previously, I'm not going to work with a SQL Server database for this service, simply just to kind of reduce time a little bit. Working within a in-memory database is fine for the video. If you are moving into a more production environment, yes, you would use SQL Server. But for the moment, I'm just going to use in-memory. That's all. And that's it for the moment. We had the swashbuckle package reference in there. Again, that's for Open API. If I remember, we'll take a quick look at that. But that's it for now. So that's our package references done. Our project is scaffolded up. What I'll probably just do is just remove the stuff that we don't want. So the weather forecast service, we don't want that. And into our controller, we'll take out our controller as well. Whoops, we'll take that out as well. And we'll delete that. Now the other thing we'll actually do is over in properties, in launch settings JSON, if we spin this up, and we will actually spin this up locally, it's using the same ports as our command service 5000 and 5001. And so when we're doing some testing, before we deploy to Kubernetes or even package up in Docker, I'm going to run them both up locally and have them running at the same time, just using the .NET command line. And so obviously we'll get an error if they're both trying to launch on the same port. So I'm just going to change the command service ports, local ports, to 6000. All right, and what we might do, just to make sure it's all wired up correctly, is just do a .NET run, because you never know, there might be some little gremlin in the system that we didn't think about. And that all looks fine, and it's running on port 6000, 6001. It's not going to do much at the moment, because we've taken out our controller and we don't have any models or anything. All right, so we'll close that down. Now in the next section, what we're going to do, what I really want to focus in on, is we're going to create a controller first. We're not going to create models or anything like that. I'm just going to create a very simple controller with a very simple post action endpoint in it. And the point of that is I want to just get our two services talking to each other. That's really the next part of the video. We will eventually come back and we'll add models and we'll add all that kind of stuff in here. But for the moment, all I'm really wanting to do is get our two services talking synchronously to each other using HTTP. We'll do that locally and then we'll do it in Kubernetes. Okay, so that's really the path we're taking next. So in the next section, we're going to create a controller with one action in it that's going to receive a post request from somewhere else. And then we're going to get our platform service to talk to it in a synchronous way. All right, so we'll do that next. All right, so we're going to create a controller in our commands service, simply at this point, just to receive a post request from something else. In this case, it'll be our platform service, just sending something over to us, really just to test synchronous HTTP communications between the services locally, and then we'll do it in Kubernetes. All right, so back over here, I'm just going to close this down, close down the command line and close down launch settings JSON. And over in our command service, if you right click the controllers folder and new file, we're going to create a controller. Now this service is going to end up with two controllers. It's going to end up with a commands controller, as you'd probably expect, but it's also going to have a platforms controller. Why? Basically because this service is going to work with two models. It's going to work with commands and it's going to work with platforms. And the way I've architected this service, basically the platform is really the parent resource of the command resource. So if you think about it logically, you're going to have a list of commands like, you know, .NET run, .NET build. There'll be loads of those and they will relate just to one other resource, the platform. Okay, so when we are using REST, as we are here, to create resources such as platforms and commands, what you should really do is split those out into two different controller actions. So we will have a controller to deal with our platform stuff, very similar to a platform service, and we'll have a controller to deal with our command creation stuff. And you'll see how that unfolds a bit later, and I've got a whole section on sort of multi-model REST APIs. But for the moment, again, I just want to focus on getting some comms between the two services. So it might sound a bit counterintuitive, but the first controller we're going to put in our command service is our platforms controller. Okay, so in controllers, create a file, platforms controller .cs. All right, fantastic. Now let's keep going, but I just want to call your attention to the fact that we are running VS Code with these three projects in here now, and that it can sometimes behave a little bit strangely, but let's see how we go. So namespace this time is going to be commands. Yeah, I think it's doing it already. Commands service. Yeah, and so we're not really getting auto completion at the moment. If you sort of see what's happening, usually if you start typing, if I started typing command service, I would get prompted with the full name of the, of the service for our namespace. But let's, it's very evident how reliant I am on it because I'm so used to that pattern. Let's keep going. Command service dot controllers. Okay. And we'll just bring that onto the next line. Okay, and it's a public class. So public class platforms controller. And we're going to inherit from controller base. And we don't have that namespace, so control period. Now, this is what I'm talking about here. I'm doing control period to bring in my list of code suggestions, and nothing is happening, okay? And the reason for that, or I believe the reason for that, is because we're running VS Code and we're now having it hosting multiple projects. So the kind of IntelliSense stuff appears not to really like that. So what we're probably going to have to do is close down our VS Code session running all these projects and reopen it just with command service, and I'm fairly sure then we'll get our code suggestions. So let me just save that off for the moment. Kill this. Actually, I won't kill it. I'll just bring up a command prompt, and then we'll come up a level, do a directory listing so we can see all our projects, and I'm just going to open code recursively, and I'm just going to open command service itself. Let's do that. Okay, fantastic. And if we come back over to our controller, there we go, it should start complaining, and I'm fairly sure if I put my cursor in there and do a control period, I will get my code suggestions again. So it's just something I've found. I'm not sure if there's any other way around it. There probably is, but for the moment, I'm fine with just running an individual project in our VS Code session. All right, so public class, platforms controller, inheriting from controller base. The next thing we want to do is decorate our class with API controller. As before, it gives us some nice default behaviors, and we're going to create a route again. Okay, so from memory from last time, API, and then you can either put in, not curly brackets, square brackets, you can put in controller. Okay, now you might see a problem straight away here, because we're going to have a route to something called API/platforms. We're also going to have that in our other controller as well. They may go, well, that's not a problem because the rest of the URL is going to be completely different. The IP address or the domain name is going to be different. Correct, that's fine. So we could leave this like this for the moment. However, when we come on to using our API gateway, things get a little bit more complex. So I'm just going to call that out now. I'm going to leave it like that at the moment. This will still work at the moment, but going forward, we are going to have to change this slightly to reflect that this is a slightly different platforms controller from the platforms controller in our other service. In fact, I'm going to put it in now, okay? Because if I forget when we run into issues, it might become a bit problematic. So what I'm going to do, and again, when we move through the rest of the video, this is all kind of hidden. Once we hide all this stuff behind an API gateway, this stuff is hidden. So you're not going to have these horrible URLs that you're going to have to deal with. But just for future proofing, I'm going to put this in. So all I'm doing here is the root is API, and then I'm going to specify that this C really is for our commands. This could be anything, by the way. I'm just putting C in. So API/C to denote our command service, and then the name of the controller. It'll become clearer later on when we move on to the gateway stuff. So bear with me on that. So that's our route. Fantastic. I'm going to create a shell constructor just so it's there, but we're not really going to put anything into it yet. Now we will eventually, like we did with the platform service, inject in automapper and a repository, but we're not doing that yet. Again, in this section, all we're interested in doing is getting an action up and running. All right, so we'll leave a constructor like that for the moment. And then we're going to create our first test action. So it's public action result. And I'm just going to call it test inbound connection. Okay, and it's not going to accept anything really. And all we're going to do is just do a console write line, keep it really simple, bring in the namespace for console using system. console write line, and I'm just going to put something like inbound post at the commands service. Okay, so all we're doing, so we hit this action, we're going to get this printed out to the screen. And I just need to make this decorated with HTTP post. And then finally, you do need to return something back as it's an action result, so we'll just return OK. And I'll put something in here, I don't know, inbound test OK from platforms controller. Quite a few spelling mistakes in there. All right, fantastic. So that probably looks a little bit convoluted. I'll put the trailing semicolon in there, and maybe some of the stuff in here going, don't quite follow that. That's okay, don't worry, it will become a lot clearer later on. So what I want to do now is just test this, okay? I'm going to test it from Insomnia just to make sure everything's wired up correctly and it's working okay. So into the terminal, make sure you're in command service. We'll do a .NET run. I don't think I'm forgetting anything, but we'll find out. And it should be running again on port 6000. Fantastic. So let's bring up Insomnia, and we're going to close all that down, and we're going to come over to our local development environment, because that's what we're running in. We're going to create a folder under here, new folder, and we're going to call it command service. Okay, and we're going to create a new request. It's going to be a post request. We'll select JSON, and we might pass some JSON over eventually, and we're just going to call this test inbound connection. Okay, create. Fantastic. And what I might do is just come in here, and I'm just going to copy this. Make sure I copy it all. And I'm going to paste it in here. Make that a little bit bigger so you can see it. Now, a couple of things here. The port's going to be different, so it's going to be port 6000, and as per our route, it's going to be API/C platforms. Okay, so back over in our controller, you'll remember, this is the route to this controller. Okay, so API/C, and it'll be platforms, because we're in our platforms controller. All right, so again, screen's running at quite high magnification, so I'm just going to click send. You get 200 OK, and we get the response back, inbound test from our platforms controller, which looks good. And if we come back over to our running service, you can see that we got this message printed on screen. Cool, so very simple, but really just setting this up to establish that we have an endpoint in our command service. What we need to do now is create a method of calling this from our platform service, so we have that degree of, so we can establish some communication service to service. We'll run that both locally, and then we'll deploy it into Kubernetes. So we'll move back over now to our platform service and write up what we're going to call a synchronous client, effectively, synchronous HTTP client. So we'll do that next. All right, now actually, before we move on to doing any coding, I do appreciate I've been talking about synchronous messaging and asynchronous messaging, and you might be going, what's this guy talking about? So yes, I think it's a good time to talk about this now. I was going to leave it till a bit later when we came on to talking about message buses, but I think since we're starting to do some messaging now, I think it's a good place to actually put these slides in. So yeah, let's talk about synchronous and asynchronous messaging. So what is synchronous messaging? In short, it's basically talking about a request response cycle type setup. Okay, so as a client, I'm going to make a request to our HTTP endpoint in this case, and I'm going to sit there, I'm going to wait until it responds back. Okay, so the requester will wait for a response. This is probably going into maybe a bit too much detail at this stage, but generally speaking, and it's probably quite a controversial statement, and I'm probably going to get lots of hate mail for this one, but generally speaking, services such as our command service and our platform services, when they're servicing requests to external clients such as a web application or Insomnia, those type of external facing services are synchronous. Okay, that's a very common pattern. When you're talking about service to service communication, i.e. within our cluster, for example, and it's just services talking to each other, you can use synchronous communication for sure, and we're going to do that. But for the most part, we, in this video anyway, are going to be using asynchronous communication, and I'll come on to what that is in a bit. That might be a bit of a controversial statement, but yes, for the most part, externally facing services are definitely synchronous. They don't tend to be asynchronous. That's less controversial, all right? Synchronous services usually need to know about each other. So as a requester, I need to go and know exactly, explicitly, I need to request that service for some reason, and I need to know where it is. Now, I put usually in brackets because there are things like service discovery and service meshes and all that kind of stuff where you can maybe have that kind of automatic service type discovery. We're not covering that here today. So for the most part, what I'm saying is if you're making a synchronous request to an endpoint, you need to know where that endpoint is. You may go, well, why is that? Why is there an issue with that? Well, it becomes a bit of a management overhead. If your service is calling another 10 other services, it needs to know exactly where all those 10 other services are in order to call them. And it becomes a bit cumbersome. We're going to be using two forms of synchronous messaging today, HTTP, which we'll come on to doing next, and gRPC. All right. Now, this bit I really wanted to put in because it can get a bit confusing. So I've just said HTTP is a synchronous messaging construct. Cool, and it is, right? So I'm not retracting that. A very good question, it's a question I had initially as well, was hang on, wait a minute, if I've written a controller, which we have done, and I've got some action results in there, I can mark those action results as async. Doesn't that make it an asynchronous messaging construct then? The answer to that is no, and I'll tell you why. So from a messaging perspective, as you can see on screen, say we did tag one of our action results as asynchronous, from a messaging perspective, the method is still synchronous. Any client making a request to that endpoint still has to wait for a response, okay? The async stuff is really all to do with the way that service manages its threads internally. From a client perspective, from a messaging perspective, anybody requesting that service still has to wait for a response, so it's still synchronous messaging. Just to clarify, async in this context, the C# language context, means that the action will not wait for a long-running operation. So say that action result is doing some lengthy database dip, or maybe even calling another service. If it's long-running, what that async keyword means is it's not going to wait, it's not going to maintain hold of its thread while that long-running operation executes. It's going to return the thread back to the thread pool. Okay, so yes, it says here it will hand its thread back to the thread pool where it can be reused. When the long-running operation finishes, it will reacquire a thread and complete, and then respond back to the requester. So all this time, the requester in this scenario has still been sat there waiting for this service to respond back. This whole async construct is purely about thread management internally for that service. Messaging perspective, it's still synchronous though. So yes, as it says there, async in this context is really about thread exhaustion. The requester still has to wait. The call is still synchronous. Okay, so async in this context is about C# language, thread management, nothing to do with messaging. HTTP is still a synchronous, by and large, messaging construct. All right. So synchronous messaging between services can and does occur, and we're going to implement this. So as I said, this is all coming back to this. Do services talk synchronously to each other? We are going to do this. However, it does tend to pair services. It does tend to couple them a little bit, creating a dependency. Now again, in the microservices world, one of the kind of tenets is that you want to try and decouple where possible. You don't want lots of chatty communication between services. They're going to have to talk to each other, and there's a bit of a paradox here, but for the most part, you don't want lots of inter-service communication, and you certainly don't want it in a synchronous fashion, I don't think. And it could lead to something called, additionally, it could lead to something called dependency chain. So let's look at this diagram here. Service A makes a synchronous call to service B. Service B then has to make calls to services C and D, and service D then has to make a synchronous call to service E. So you can imagine if there's delays between any of those request response cycles, or if one even fails, what's going to happen. not a fantastic result. And service A is probably going to be sitting there waiting for a long time. You also have this horrible kind of, the name says all dependency chain, where each service needs to know exactly what other service to call. It starts to get a bit cumbersome. You might have heard the term spaghetti programming, maybe not fully applicable in this state, but you get the idea. It becomes a bit of a mess, okay? But nonetheless, we are going to implement it to begin with, and there are scenarios where it's probably the better pattern to use as opposed to using an asynchronous event-based pattern. And we're going to implement that with gRPC a bit later. So I'm not saying you don't use synchronous communication. I'm just saying you've got to, as a developer, you've got to make that decision about which is the best to use from a service-to-service perspective. All right, so asynchronous messaging. There is no request-response cycle. The requester does not wait. Sounds good, doesn't it? It's more of an event model, and for example, a publish-subscribe type model. Typically used between services, again, might be a controversial statement. There's some people out there that would probably disagree with that, but this is my video and this is what I'm saying, so go with it. Event bus is often used, and again, we're going to be using RabbitMQ much later down the path. We'll introduce RabbitMQ. And services don't really need to know about each other. They just need to know about the bus. So the idea is, as a requester, I just need to talk to the message bus and put something onto the message bus and go, here you go, here's something that other services need to know about, or here's some information that I potentially need. And I just put that onto the message bus, and the message bus sends out these events to any other services that are subscribed to those events on the message bus. Those other services will receive an event, go, oh, okay, I've got this new event, and then will respond back onto the event bus in that kind of fashion. So it's event driven. The event bus kind of sits as an intermediary between services, and it's a publish, subscribe type model, event driven model. And we're going to go into that quite a bit in this video. It does, though, introduce its own range of complexities, and it is actually much more complex than a synchronous request response cycle. It does introduce a lot of other things, that make it more complex. It's not a magic bullet by any means. So then the final slide in this section, and it's a question I wanted to surface here, is, isn't the message bus a monolith? It's this big thing that all these other services are dependent on. To some extent, yes. And it's the same kind of conversation you'll have about API gateways. Is an API gateway basically a monolith? Again, to some extent, yes. But focusing in on the message bus, is it a monolith? Yes, to some extent, yes. Internal comms, if services are reliant on the message bus, internal comms between services would stop working if the message bus went down. However, if you've designed your microservices appropriately, those services should be autonomous enough that they can still deal with external traffic, they can still deal with requests to them and be able to deal with them to some extent, even if they cannot talk to other services internally. So yeah, services will typically still be able to operate and work externally, with some caveats, of course. The message bus, therefore, because it is so important, should be treated as a first-class citizen, similar to the network, physical storage, power, any of that stuff. And so typically, when you're setting up a message bus in a production environment, you'd set it up in a clustered fashion. You would have fault tolerance, you'd have multiple instances all talking to each other, so if one goes down, it's not an issue. And again, that's how RabbitMQ themselves recommend you set up RabbitMQ in Kubernetes using this cluster type approach. We're not going to do that here. It's a bit too complex for this video. It's just an introduction video. So we're just going to set up a single instance of RabbitMQ for our purposes. But generally speaking, in a production environment, you would have this cluster. The other thing I put there is you'd also typically have, a degree of persistence. So if your cluster dies and then it restarts again, it's not lost all the messages that it had in the queue. It should have some degree of the ability to retrieve messages it had in its queue from some persistence layer. That being said, services should also implement some kind of retry policy. So say the message bus goes down, you don't want to just fire messages onto it, and then if the message bus is gone, you've lost that event. The services should be intelligent enough to retry, keep those events queued up and retry when the message bus comes back up. So something you'll hear about often in the microservices world is you aim for smart services. Your endpoint should be intelligent, the pipes should be relatively simple, or stupid, as I've put there. Okay, so they're really just there as a transport to get one event from one service to the other. All right. So with that, yeah, again, I just wanted to introduce you to this concept of synchronous messaging. We're going to be talking about it a lot, and asynchronous messaging, we're going to be talking about it a lot. When we come on to asynchronous messaging and RabbitMQ, we'll do a full section on that a bit later. But for now, we're going to move back over to our platform service and implement a synchronous client that will allow us to talk to our command service. So we'll do that next. All right, so back over in our command service, we're not actually going to work in our command service now. We've got everything we need in here for the moment. So I'm just going to close down the running service. Now, I'm going to leave our command service running in this instance of VS Code, and I'm going to bring up a separate instance, a new window, for our platform service, because we're going to be working in there now. So in our new instance of VS Code, I'm going to move into my working directory, season 4, and change into episode 3, and I'll do a quick directory listing to make sure I can see a platform service, and then we're just going to open that in this instance. Cool. All right, so we have our platform service up and running now. So yeah, what we're going to do is create a HTTP client effectively. It's going to issue a post message to our command service. Now this is just a test really, we're not really going to implement too much functionality here. But the idea would be that if we created a new platform in the platform service, that we would want to let our command service know about it, because our command service is somewhat reliant on platform information. And one way we could do that is by sending a HTTP post payload over to our command service, and it could then take that and do with it what it wants. We're going to properly implement that using a message bus type construct. So using an event publisher subscribe type model, we're going to properly implement it doing that. Here, we're not going to fully implement it. All I really want to do here is just make sure that we've got comms working between the two endpoints, more especially when we come to putting it into Kubernetes. This is more actually a Kubernetes thing, really just setting up the networking between our services. And I'm doing this just to test that, help test that. Nonetheless, it's still a valid use case, and we want to make sure that it's all working. So back in our platform service, we're going to create a new folder for our synchronous data services. So new folder, and I'm going to call it sync data services. And we're eventually going to end up with two types of synchronous data service, HTTP that we're doing now and gRPC. But we're going to just focus on HTTP for the moment. So new folder, HTTP. I'll make sure I capitalize H. All right. Now, we're going to make use of something called a HTTP client to make the request, and moreover, we're going to make use of something called a HTTP client factory to basically give us a HTTP client. And then, I've done videos on this before. The main reason we're using HTTP client factory is if you're making multiple requests using HTTP clients, you should be using a factory to do that for you, because it just manages connection safety and all that sort of stuff, and you don't end up with, again, connection exhaustion and all that sort of stuff. So we're going to be using a HTTP client factory, but if you follow along with the code, it should be relatively straightforward. So the first thing we're going to create is an interface, because we are going to use constructor dependency injection, and we're going to inject this client into various places, namely our controller. So we want to allow constructor dependency injection from that perspective. So new file, and we're going to call it I command data client.cs. And then we're going to define namespace, platform service, sync data services.http. Fantastic. And it's just a public interface called I command data client. And we're just going to have one method signature. It's going to be asynchronous, and you'll see why in a moment. So we'll have to bring in the namespace for task in a second. And we're just going to call this send platform to command. Now, we're not really going to do anything with this, but I thought just to kind of make it a bit more of a realistic example, if we come over to our DTOs, the idea is we want to send over a platform that we have created. And we have two DTOs here. We have our platform read DTO with all this information in it, and we have a platform create DTO with this information in it. Now, I'm thinking in this case, when we send a platform over to our command service, we probably actually want to include the ID, our ID, because we probably want to give it a reference, a unique reference to the platform that we've created, so it has that. So I'm going to use the platform read DTO as the message that we pass over, okay? So in here, I'm going to say platform read DTO, and we'll just call that plat. So we're going to bring in a few namespaces here, so control period to bring in platform service DTOs, and we need to bring in threading for this. Okay, great, so that's our interface created. So I'm just going to come on now and create the concrete class. So again, within the HTTP folder, new file, and I'm just going to call this HTTP command data client.cs. Okay, specify the namespace, platform service, sync data services, and as we've typed this in before, you can see it's remembered it, which is cool. And then it's just a public class called HTTP